So this is working if you want to use that.
Good morning, everyone. I'll try not to lose my voice while I talk. I've been having a lot of issues this morning with my voice, but I'll do my best. If whatever something happens, Audrey is ready to kick in and take over, as is Jenny, I believe. But I'll do my best here. Welcome to our first stakeholder workshop for the National Science Foundation Research Traineeship Program, which is the name, as you can see, Stakeholder Guided Environmental Science, stands for STAGES, is what we're trying to, it's a part of what we're trying to accomplish here today. So, well, no, not that. Okay, I'm good. Before I go into introducing the program a little bit more for our guests, you have on each table, you have a flyer where you can find information where the restrooms are here in UC, as well as what you need to do to connect to Wi-Fi. If you do have issues, your person is Audrey, and I think by now everybody knows who Audrey is because she's been the heart of this workshop. She's organized most of it by herself. We just a little bit of help here and there. I wish we could do more, Audrey, but you see us. We try our best. So anyway, if you do have any questions about any of this, please ask Audrey or any of us. Should work. So what the purpose is, it's the traineeship is to fund graduate students to be trained on research, and that's, the research can go different directions, and one is, you collect the data, you find ways to interpret it, and one of our big components is also data analysis and working with big data and then connecting with the stakeholders to co-create questions, research questions or knowledge. So they gain knowledge from what the stakeholder needs are, and they can then connect and potentially make lifelong connections and mentorships, right? And also to work interdisciplinary. So really our hope and goal is that at the end of their 1-year training, our graduate students, trainees, which we call also fellows, will learn a lot more about their colleagues' fields and research and find valuable knowledge to apply to their own research. But today, here, they're going to listen to our stakeholders that did agree to present and to communicate to them what their research interests are and what data are available. And we hope they'll be finding common interests to group around research questions that they can answer from different perspectives. So then we can have a better understanding of how we might resolve certain problems. So we got funded last year. I am the PI, but this grant and this program would have not been possible and funded without my my colleagues, Dr. Jinping Hu, Juntao Liu, Jenny Polak, and Dr. Tissot here, as well as our stakeholders that did agree to work with us, because that was part of the proposal. And that was ultimately what made our proposal really attractive, that was funded. So what we're trying to do, again, connect students with stakeholders, generate a list of big data-oriented problems, co-develop research questions, interest to stakeholders that students might work on over the next 5 to 6 months. So there's going to be a summer course for them to gather the data, process it, get it ready for later environmental forecasting course in fall with Dr. Tissot that they're going to finalize the project, hopefully. However, if they don't get to a satisfactory maybe outcome, that there's still something is left to do, we have a new cohort coming in, and they are the ones that are going to still be here next year. Would like for them to stay involved with the new team and mentor the new trainees. So there's going to be continuity, hopefully, with this. So our agenda for today, we have stakeholder presentations from 9:15 to 10:45. I understand there's a 30-minute talk for each one. 15-minute break, resuming with presentations. Lunch is between 12 to 1, and hopefully you take an that opportunity to mingle and connect. With more presentations until 2, and then we'll have questions for half an hour, and then we'll try to see where the common grounds are and the interests are. So Stages seeks to connect innovative research to practitioner and community needs to answer stakeholder guided questions, as I mentioned already, of regional and national concern. I always get ahead of myself, but now I'm just going to have to read over that slide. So who is present here today from our stakeholder organizations? The Ingleside on the Bay Coastal Watch. I believe have Patrick online. The Meadows Center for Water and the Environment at Texas State University, also I believe online. Mission-Aransas National Estuarine Research Reserve, we have here in person, and each one of you will introduce yourselves when you present. National Weather Service, Port of Corpus Christi, partially online, I believe. Texas Sea Grant, Calhoun County Extension Agent, we have here. And Texas Water Development Board, our alumni. Evan. Okay. Probably everybody already seen the pictures and our trainees, our fellows, but this is again a refresher of who they are. And if you all would like to stand up so everybody here in the audience can identify you. So our trainees, please, just. Excellent. Thank you for being here. They're great. We spent 3 days out on camping, so we made it back. We're good. It was a great experience. We loved it. And faculty advisors, some of them are present here, and others could make it, but the reason they are here, or ideally they would have been here, is because we also want them to connect with our stakeholders through their students. But if you learn and know about what your next proposal might be, this is a good place to be. So you learn about stakeholder priorities. And did I speed through? I did. I'm good. Okay.
This is working pointer events.
Okay. Hey, good morning. Man, I had to be the first one. Okay, there's coffee over here. Keep a reminder. If I see you falling asleep, come get it. I'm happy to be here today to talk about a couple different data sets that we collect. I'm at the University of Texas Marine Science Institute in Port Aransas, Texas. I'm the reserve director for the Mission-Aransas National Estuarine Research Reserve. And so I'll tell you a little bit about the research reserve system before I get into the data, because if you're interested in working with the data that we're collecting, there's a number of benefits to that as being part of a whole system. So there's actually 30 reserves around the country. Next year, there's going to be 31. Louisiana's about to come on board, so there'll actually be one, at least one in every state in the Gulf of Mexico. But the interesting thing about the reserve system is that we all collect the same type of data, at least for our core areas, and we use the same type of equipment. So you can compare what we're doing right here in Texas to anywhere else in the country that has a reserve. And so I'm going to go through a little bit about that for you. And then I'm going to tell you exactly how to download the data. So our kind of working boundaries is Aransas Bay and Copano Bay. And that's the bay system just north of Corpus Christi. And you can kind of see our boundaries on this map. They're in red line. We actually have a 3,200 acre piece of property along the Mission River, up at Finney Ranch, and then down to Copano and Aransas Bays. And so it's about 186,000 acres that we manage, and we conduct research, education, we have trainings, and a stewardship program. Our core area that we're at, kind of our offices are in Port Aransas. And so how many of y'all have been over to Port Aransas yet by the jetty? Have y'all been to the jetty? So we're located right by the jetty. There we have a channel, the Aransas ship channel that goes through right there with a pier on it. That we have a lot of research equipment. And so I'm going to show you a map here in a second that has that pier on there. So it's some of the places we're collecting the data, plus up in that Aransas and Copano Bay area. But it's kind of a perfect spot for if you're doing marine science and data gathering. Within the reserve system, all 30 of those reserves, we all have 4 sectors that we work in. So we have a research sector, stewardship sector that goes out and works in the community, doing cleanups, working with landowners on how they can better manage their land for conservation and environmental purposes. We have a training program where we bring in a lot of state and federal agencies. So as we collect this science, we're trying to, it's all applied science, which means we can actually use the data. So we bring in the people that are making decisions about our natural resources. And so the data we're collecting is going towards that and trying to answer questions that they might have on so that they can better make decisions about our natural resources. And then we have an education program. And so that's K through grade. We have K through 12 and then also public. So we have public seminars that we do. We do tours of not only our facility, but birding tours up at the Finney Ranch I was telling you about. And then K through 12, we see thousands of students. We bring them onto campus. We have a research vessel that we can take 25 students out at a time. And we have shrimp nets on there, pull it up. It really gets that next generation interested in, what's living in the bay, how can I get involved and trying to make the next generation of leaders. And then our reserve is the only one that has a rehab facility. We rehab sea turtles and birds. And so I'll show you a little bit about that and tell you about some of the data that we collect. So the different types of data that we're collecting, we have our system-wide monitoring program, which we call SWAMP. That's the one, the SWAMP data is what all the reserves are collecting all around the country. And that's the one I'm going to go through in detail and show you how you can download the data. It's easy to get, and we have a long data set that if you're interested in that one. And mainly we're going to focus in on the water quality part of that. We also do have vegetation transects where we're going out into the marsh and we're seeing how the marsh changes over time. Y'all know with sea level rise, habitats are changing. We have surface elevation tables, which I know y'all know Dr. Ed Profit out here, that he has some of those around the coastal bend as well. We focus ours in on the Mission-Aransas kind of working boundary. And so that's where we're looking at erosion and accretion rates within the marsh and how that's changing over time. And then our sea turtle and bird stranding data. So we are out every single week looking for stranded sea turtles. And on a daily basis, we're getting birds in. We get about 1,500 animals in a year, about 1,000 birds and about 500 sea turtles. And right now, from April 1st to mid-July, we've actually got nesting sea turtles. So we're out every single day right now going out looking for nesting sea turtles. So we're gathering that data as we find sea turtles. We excavate the eggs on Mustang Island and San Jose Island. And then we take those eggs down to the Padre Island National Seashore where they have an incubator down there. But we're collecting data on how many eggs we find, where the turtle is. We tag the turtles. So if they come back up, we know why they came back up. And same with the stranding turtle. If there's a turtle that just washes up on the beach randomly, we're collecting all kinds of data with that as well. There's some interesting stuff there, but I'm not gonna, that data is not as easily accessible. So if y'all are interested in that, I mean, I can get it for you. But we're gonna go on to citizen science data. We have Little Bay water quality sampling. So we have about 4 volunteers that live up in Rockport. There's a bay up there that's called Little Bay. It's actually a little bay. And they've been collecting data for, I don't know, probably 7 years now, where they go out a couple times a week and look, it's basic turbidity, pH, salinity, temperature, things like that. And then we have Nurdle Patrol, and that's where we have citizen scientists going out, collecting data on plastic pellets that are along beaches, rivers, and lakes. And so I'll get into more detail about that. And then we have a lot of individual projects. So just like here at Texas A&M Corpus Christi, you know, we write grants, we get a project, it might last a year, it might last even 10 years. We're gathering data with that. The two I want to focus in your attention on, and I'm going to talk in detail about today, is this swamp data, the water quality section, and then also the Nurdle Patrol, because those are easily accessible databases that are pretty large, and there's some unanswered questions that y'all could help fill. So with swamp, this map here kind of shows our 5 locations of where our platforms are. And so the image in the middle are the platforms that you'll see out into the bay. They have YSI sondes on them that have a lot of different probes. We're collecting temperature, chlorophyll A, turbidity, temperature, pH, you know, kind of a lot of the typical stuff. And then a couple of these also have weather associated with them. And so all this is real time. You're able to go in, download the water quality portion and the weather. And so the weather stations are the ones that are on that pier I was telling you about, that's right in the channel. And then also in Copano Bay, there is one that's on the eastern side of the bay that has weather associated with it. And so I want to tell you about how you can go in and download this. We started collecting the data in 2007, and it's every 15 minutes, 24 hours a day. So it's a lot of information. And those dates are helpful for whenever you're going to go in and try to download the data if you're interested in this project, because you're going to have to put in the dates. But if you go, we house all this real time with NOAA at the Centralized Data Management Office. And you know, in science, we have to have acronyms, right? So CDMO is what we call it. And so I'll just refer to it as that. So if you type in CDMO into your website or into your Google, this is what will pop up. It'll be the homepage, and it'll have a map on there of the United States, and it'll have all the reserves on there. And so all you do is you click on that map. And once you click on that map, then you'll go to the next image here. Let's see. So you click on that map, then you click here. So I'm kind of going right, left to right. You click on the middle one, and it'll say there that you know you want to download the data. So you click on that, and then it takes you to the map again. But this map, it actually gets you to the state that you want to look at in the reserve you want to look at. Once you do that, click on Mission-Aransas. And the reason, and let me back up here. What's good about this, being able to get to any of them on the US is that, say, I don't know where your hometown is, maybe you're from Corpus, maybe you're from Washington State. Maybe you want to compare the data that, we have here in Texas to Washington State. So just come back to this map, click on Washington, and it'll take you to the data set for Washington. Then you have two data sets to compare to. After you click on Texas, it's going to pop up right here on the left-hand side, a map of Copano and Aransas bays. All 5 of those stations I was telling you about are going to show up. And so then you just click on whichever station you want to look at. So not only I use that comparison of Washington to Texas, but even in Texas, you've got 5 different stations you can compare. I mean, this is a lot of information. So you just click on which one you want, and then the middle slide comes up, and this is where you can graph your data. So you can actually, if you press that button that finger is on, you can actually create graphs right from this. So it's not actually downloading it, it's actually just creating a graph that you can screenshot and take out if you didn't want to actually download the Excel. But if you do want to download the Excel, then it's the other button. So you see on the right-hand side, there's a download button. Just click that, and then what comes up, you're going to have to actually put the dates in that you want. So it can be from, whatever date it is in 2007. And it tells you there on the screen, actually, the first day that we started collecting data, but they're in 2007 till today. And I'll go through each one of those here. So on the left-hand side, that's what the graph looks like if you want to graph it right in the program. And so for this one, I believe that might be water quality or something like that. Or sorry, it might be temperature. I can't remember what I did. But then on the right-hand side, this is the tricky one. So it's not going to download it right to your computer. It actually emails the CDMO folks that are in South Carolina, and you put in your dates there, and then they're going to email it to you. So it takes about 15 minutes, and they email you an Excel spreadsheet with all the data in it. Okay, so how could we use some of this information? So y'all are trying to develop your projects, right? Here's some ideas for you. We do a lot of data collection at the reserve, but we don't necessarily do anything with it. It's more for the public to be able to take it, or state and federal agencies to use it. So this is this means it's a good opportunity for y'all to be able to see what y'all can do with it. So this first one I hear is looking at trends over time and compare maybe with habitat changes. So you can go, if free software, Google Earth shows habitats. There's actually, if you know GIS, there's even better resolution for habitat changes. And then also Parks and Wildlife, they also have some really good data sets, and they look at, whenever they're doing their fish surveys, they're looking at habitats along the shoreline. Now, they just started that, I don't know, 3 or 4 years ago, somewhere in there. But if you're able to get the Parks and Wildlife data set for their gill nets, trawl nets, and seine nets, bag nets, they actually, you could use their data and look at the water quality data that we have at Mission-Aransas Reserve. And then maybe also compare with oyster closures of the bay. So these are just ideas for y'all to get thinking. There's a ton of other things that you could do with these data. But this is for y'all to look and say, oh, well, Mission-Aransas Reserve only has this and we're stuck with that. No, you can go to other agencies and get information from them to be able to compare and just use the reserve data as kind of your baseline and compare changes going on within the system. So that's some ideas for you. Any questions about that one before I go on to plastic pellets? No? Okay. Oh, here. Okay. Right. Yeah. Parks and Wildlife doesn't keep their data up even though we've requested this many times that they do that, but the reason they don't is because lots of times they need to explain the data to you. They don't want somebody to use the data in the wrong way for Parks and Wildlife. Okay. So NRTLs, how many of y'all have heard of what NRTLs are? Anybody? Okay, most of y'all have then. Okay, so I don't have to go into a lot of detail, but basically it's the raw material to almost everything plastic that you use. Small plastic pellets, you considered microplastic, so less than 5 millimeters in size. We're finding these all over our beaches, in rivers, in lakes, and along railroads. So I'm going to go into a little bit of detail. Here on the right-hand slide, you can see these are NRTLs. They're different shapes, sizes, colors. These are all the basis of kind of everything plastic that we use. There is an impact to wildlife. It's probably the biggest impact. We know back in 1992, the EPA, the Environmental Protection Agency, came out with a report that had about 80 species that they knew about at the time that were eating these plastic pellets, including shorebirds and sea turtles and fish. So now we know there's actually hundreds of species, but this just goes to show you it's been a problem for a long time, for over 30 years. The other issue is chemicals can be absorbed to the outside of them. And so there's all kinds of issues with chemicals inside of the bodies of animals. And is there an impact to humans? We don't know that answer yet, but there's people researching that. Hopefully we'll know in a few years. So we came up with this idea of a citizen science project where citizens would go out and they would go out for 10 minutes and look along shorelines, river banks and lakes and see how many they could find in 10 minutes. How many of these pellets could they find? Then they would go to nrtlpatrol.org and put that information into a mapping system. And so this is kind of the methodology is real simple. And we have a 4-minute video that kind of tells you how to do it on the webpage at nrtlpatrol.org. So if y'all are interested in this project I'm going to be telling you about, it'd probably be important for you to go to the website and watch how citizen science are collecting this data before using the data. It might be helpful. The methodology is also published and it's open source, so it's free to download. It's on the homepage of nrtlpatrol.org. So this will be important too as you're developing your research project to be able to look at that paper. After citizen scientists go and they collect their 10-minute survey, they go in and they put it into a data portal, and then it shows up as a colored dot on this map. And this is like a Google Earth type platform. So you can zoom into your house or you can zoom out as far as you want and see the whole globe. But these colored dots represent the concentrations of NRTLs found by one person in a 10-minute period. So you can compare what they're finding in Florida to what they're finding in Texas versus, East Coast, West Coast, or anywhere in the world, actually. And so I'm going to tell you a little, I'm going to zoom in here in PowerPoint. So keep that in mind. And I'm going to tell you a little bit about what these colors mean as we get closer. So here in Texas, we have a lot of reds you can see on the map. Reds are actually 101 to 1,000 NRTLs in a 10-minute period being found. That's pretty typical along the Texas coast to find over 100 in a 10-minute period. Now you saw a lot of greens over in Florida, right? Greens are 0, so that's data as well. We tell people, even if you go out and you don't find anything, put it on the map because that tells us something. No NRTLs there, or very few NRTLs, if there are any at all. But when you look at this Texas map, you probably think, what's the deal here? There's some that aren't on the coast, right? Well, a lot of these are on rivers, they're in lakes, or along railroads. And so kind of the hot spot for the country and plastic production is around the Galveston area, so Houston. Galveston Bay, you see purples, that's over 1,000 collected in a 10-minute period. That should blow your mind and be like, hey, I want to work on this project. This is the data set I want to work on, figure this problem out. So let's zoom into Galveston. So, initially when this project got started, which was back in 2018, people were thinking, well, I think all of these are just coming from a ship that spilled all these offshore. And it's just what's washing up. Well, if you look at Galveston Bay, and you look 20 miles up into the bay system, they're still finding super high concentrations. Like it's not uncommon to find 500 to 1,000 in a 10-minute period. I mean, that's a lot of nurdles. So if this was coming from the ocean, from a spill offshore, you wouldn't be finding concentrations like that way up into the bay system. This has been pretty eye-opening in what this program is ultimately trying to do, which is to change policy about how these plastic pellets are being handled by the companies that either make them, transport them, or ultimately make something into the nurdles, like plastic water bottles. So let's look at Corpus Christi. So we're kind of zooming into the local area here. You can see the beaches. There's a lot on the beaches. And I'm working with a high school student who developed a model. He's in California. But he developed a model looking at if there was a spill at the mouth of Galveston Bay, and if there was a spill at the mouth of the Mississippi River, where would those end up? And within a 2-month period, they're ending up on the Texas coast. And so we're trying to get this published right now. But just to say that a lot of what we're finding here is probably coming from Texas, Galveston area, and the Mississippi River, which drains 41% of the US. But what I want to show here is that look inland. There's like this line that goes down the coast there, right? That's about, I don't know, that's probably 10 miles in, somewhere in there. That's the railroad. So they're finding them along railroads as well. And that's how one of the main ways that they transport these pellets to the factories. So the latest stats, there's about 7,500 volunteers that are involved. Over 17,000 surveys at over 7,000 sites. And we work with about 250 partners across the world that have taken on in their own organization, either started up their own citizen science project, or they've incorporated nurdle surveys into their own organizations. And then we have somewhere around 1,800 teacher kits that we put together. And that's to teach students about what plastic pellets are, how they get into the environment, and then the curriculum is that the students are figuring out how to solve the problem of plastics in the environment. But if you're interested in this project, I'm going to tell you how to download the data. And luckily, the Conrad Blucher Institute are the ones that manage the website and the data that's collected in here. And they recently just came out with a tool to where you can download it directly from the website. And so if you're on the homepage of nurdlepatrol.org, you can click on view data. It takes you to the map. And so this is that Google Earth type map I was telling you about. If you look in the right-hand corner, it says export. And so you just click that, and then you can download the data from there. You can download it by state, you can download it by country. There's a number of different ways you can download it. Or if you like doing polygons and you'd rather say, well, I want a specific polygon area, on the left-hand side of the map, you just click polygon, and you can draw your own polygon, and it will download it all from that area. And so this is what it looks like. After, no matter which way you do it, if you do the export way or you do the polygon way, it'll show up looking like this, where it has all the data in there, and then you just press if you want a CVS file, you want an Excel file, all that. Okay, so ultimately, so that if you're going to be messing with this data, what do we want to get out of it? Well, we believe that stricter stormwater and wastewater permits is the way to go, and that the Texas Commission on Environmental Quality in Texas anyway, every state has their own agency that should be regulating these companies that handle plastic pellets. We believe that the Texas Commission on Environmental Quality could manage the stormwater and wastewater permits better with the language that's in them to say zero plastic pellet discharge. And we can also, there needs to be strict enforcement. So if an inspector goes out and they find plastic pellets on site, they need to say, look, you need to have some best management practices in place to be able to prevent this from happening. or we're going to come back in 2 weeks and we're going to fine you. You know, money talks sometimes in the industry side of things. Ultimately, if we could get these nurdles as categorized in hazardous material, that would basically solve a lot of the problems, because they would have to be handled differently. They'd have to be handled like oil is handled. So there's specific containers that has to go in, labeling, you know, if it definitely can't be on the ground. So, you know, ultimately we'd like to do that. And that is being pushed at the national level and the international level right now by a number of organizations that we're providing the Nurdle Patrol data to. So this is important. So what can be done with this that we're not currently doing? You could look at trends between the different states, figure out which states have enough data to make policy changes. So there's a number of states out there that have actually collected a lot of data, but they don't have an organization that's really kind of made the push to go to the legislatures and say, look, we need our state agency to start making changes here. Or maybe there's a state that we know they have a lot of plastic manufacturing, but they're not collecting data. You know, can you figure out the organizations that are in that area that we could approach to be able to start collecting data? You know, and so these would be other research institutions, maybe some nonprofits. Schools have been really good about going out and collecting data as well. Another one, what states need data and who could organize to be in charge leading that? So I kind of talked about that already. Look at the NOAA weather data. So this would be taking other data sets that other organizations collect, like the National Oceanic and Atmospheric Administration, NOAA, looking at their weather data and kind of compare it to the nurdle concentrations that we're finding. And so we collect data on new strand line and old strand line. So that's kind of, you can look at that on the beach side of things as tide line. So at the new tide line, you could actually compare, that's where we consider the new tide line as the tide line within the last 24 hours. So people are finding nurdles at that tide line. You could actually compare. It's like, well, what was the wave height? Was it raining? You know, what were the water levels? What was the wind like? And try to figure out, you know, where, why we're seeing higher concentrations at certain times of the year. You know, so these are just looking at different trends over time. So with that, I'd like to thank, you know, there's a lot of you know, I said 250 partner organizations that are involved in this, but there's actually some real key organizations that help to get us where we're at today. You can see Conrad Blucher Institute's on there. But if y'all have any questions, I'll take those now. I put my email up here, jace@utexas.edu. I'm not going to be able to be here tomorrow, so feel free to reach out to me anytime if y'all have any questions, and I'd be happy to have a Zoom call with you to be able to figure out, you know, where your project would go after that. But I can take questions now if you like.
Jace, I got more of like a comment. As the day goes on, and we'll see different presentations by people about how you can take different data sets and combine them from different groups. And so, for example, you know, basically looking at nurdles and then sort of where do they end up? One of the things we do is not even in the presentation. We're heavily involved with oil spill modeling from the GLO. In fact, remember the oil spill that happened down over here recently? We were involved with modeling for that, and then that's part of our contract. So we regularly model particles. So if you were so interested in, say, modeling the distribution of a nurdle spill, that would be a great idea for a student to collaborate with us to do that.
That is like a perfect project. If somebody can kind of mock up a spill and then tell us where it's going to be in 10 days, in 1 month, 2 months, 6 months.
I could absolutely do it.
Yeah. So between Nurdle Patrol and Water Development Board, we got it. And so I don't know if people could hear online. They probably couldn't hear the question. How many people are online?
We've got 4.
Okay, so online, the question, it was more of a comment, was that, you know, as we go throughout the day, there's going to be other organizations that have data sets that could be used alongside some of whoever's presenting their data set. So In this instance, it was a water development board that could forecast where Nurdle spill might end up in, a month or something, something like that, because they do that for oil spills already. So great comment. Any other comments or questions? Okay, I'll be here all today. Okay, here, we got one.
Do you have a case where there is a likely source and then flooding event or other that could be coupled, a past event where we know they're nurdles, think where they're coming from?
Yeah.
So like the spill is one thing. And, I'm also thinking the nurdles themselves will act different than oil, right? And an oil spill model, when you plug in what kind of oil, that data is not known. So that's a research. And there's also like what you're saying of because these are out and about moving, just the normal forecast of the normal tides. Well, this area is never going to have nurdles because of the seasonal wind changes or something like that. So there's whole different research questions you could pose that could be combined with that.
Right.
It's like not just here's a spill and a release. So that's a solid one that could be done.
Yeah.
But these other ones as well, like, okay, why do these beaches never get any? Well, it's probably something to do with the winds and the tide. And then all these other beaches are always going to have a ton, no matter what.
Yeah.
Right.
Okay, so the comment was is still looking at the data, but also why do we have high concentrations in certain areas and not in others? Looking at the modeling and circulation of currents, things like that. Okay, I'll be here all day. So,
Thank you, Jace. Up next, we have Patrick Nye and Jennifer Hilliard from Ingleside on the Bay, Coastal Watch Association. And you guys should be able to share your screen.
Oh, okay. I thought we sent the presentation for you to run.
We can do that too.
We can, I'm gonna have, if we would be better if you did it, I would have to switch to a different computer to run this show from where I am now.
Yeah, and I'm going to, I have a bigger computer that I can see the screen better. So if you want to run it, I'll just go ahead and put my video off. And I guess we can start from there when you get it rolling. So are you gonna start the screen for us or?
Yes, I can. We're trying
okay,
to figure out audio for a second.
Okay.
Okay. Can you guys test real quick?
Can you hear me?
Yes.
Yes.
All right.
Okay.
Well, thank you so much for allowing us to be a stakeholder in this very valuable group of trainees and just the professors and everybody we've been dealing with. And I want to thank Dr. Tissot for getting me in this job of Ingleside on the Bay Coastal Watch as president and organizer, co-organizer with Jennifer and others. I was actually had several other jobs, and then now this is most of my life. And it's very important because it's about the coastal bend, it's about our bay. And we formed a 501c3 nonprofit organization in 2019. And we were concerned about relative sea level rise that Dr. Dussault scared the life out of us with his presentations over here. And since then, we've seen rapid industrialization, more ship traffic, along with the the relative sea level rise. You can go ahead and go to the next slide. Ingleside on the Bay is a beautiful place. It's on the north side of Corpus Christi Bay, juxtaposed to TAMU-CC. We see the sunsets all along the shoreline of Corpus Christi over toward Portland. And it's just a gorgeous place. It's the industrialization, though, has taken its toll. And I'm really concerned about what's transpiring. We have several ideas to talk to you about and a lot of data. So it's how do you want to help us become more of a smart community and be able to provide information to other organizations to protect what we have, which is our bay. The next slide, I think, will show you what we're doing. We have, we're utilizing science. I'm a zoology degree from Texas Tech, and I did go out there to Port A, University of Texas Marine Institute in 1975 with some of my fellow West Texans. I'm born and raised in Corpus Christi, so they were out of the water. I was in it, actually. But using science has always been my background. I'm a geologist. We also do renewable energy. So I have a lot of cross-educational variations and using that to try to help the community and their coastal bend in understanding what's going on here. So we're looking at just the subsidence, we're looking at air and water quality, we're looking at seagrass, the economic valuations, and our cost to our community. We have solicited grant money for studies, equipment, and for community resiliency programs and outreach. And we are developing working relationships with industry, state, local, federal authorities to implement short and long-term mitigation and resiliency strategies. Next, please. So here we are, Ingleside on the Bay, and Jennifer, is this for you? Jump in, right?
So Ingleside on the Bay is at a unique position within Corpus Christi Bay. We're right at the juncture of the La Quinta Channel and the Corpus Christi Ship Channel. And since 2015, this area has seen an explosion of industry all around us. And so as you can see from this picture, our closest neighbor is Enbridge. Actually, our three closest neighbors are three oil export facilities, Enbridge, Flint Hills, and Buckeye Partners. Our closest neighbor is Enbridge, which is the largest oil export facility in North America. And then Flint Hills, which, as you heard earlier, is the source of the Christmas Eve oil spill that reached all the way over to the shores of A&M Corpus. So next slide, please. This, since we started our organization, really has prompted us to look at what is going on, not only regarding industry, but environmentally around us. When we started noticing the relative sea level rise and the explosion of industry, we wanted to come at it not just from a scientific background and really understand what was going on around us so that we could comment and effectively and mitigate it effectively. So we've worked with several of the professors and academia at A&M Corpus, with engineers from other areas of the state, and also academia at the University of Texas in Arlington. So this is a list of completed and ongoing studies that we have going on right now. Next slide, please. So to go a little bit broader view on what you see in this area where Ingleside on the Bay is, what you're seeing here in yellow are the original in green are the original our U.S. Army Corps of Engineer permits that are seeking expansion in this area. The orange names that you see here are industries that have been here since 2015. The purple squares that you see are pending permits that are expansion projects that are looking to expand into this area. So you can see one of the reasons why we're seeing so much growth is a lot of this attention that we're getting. And the dark blue is the proposed solar and carbon capture facility that the Port of Corpus Christi is proposing above Ingleside up towards Aransas Pass. So included in this are 2 desalination facilities that are seeking permits to intake and discharge within La Quinta Channel. The bay, as y'all know so much about, and it's a very slow moving bay, and so there's not a lot of exchange in these. All of this growth is very concerning to us and is currently impacting our community. And so it motivates a lot of the studies that we are supporting and that we're currently have ongoing. Next slide, please. So one of the first studies that we initiated once we became a organization was a relative sea level rise. This is a city that's a perfect example of the need to understand the impacts of relative sea level rise. So soon after being formed, we requested a study be performed by Mott McDonald to assess the risks. I'm not sure why it got all squished like that when I sent it, but you can see that there are plenty of flooding examples from storms and from nuisance flooding and high tides in our community. Part of this was we educated our community. Dr. Tissot came over to Ingleside on the Bay, and as Patrick said, really enlightened us of what was going on and what we could expect. So that really motivated us. And so this study that we had performed indicates that we've already seen a 1 foot 4 inch rise since 1967, and the flooding is more frequent and projected conservatively, a conservative increase by 1 foot by 2040. Next slide, please. Oh, there's most of those pictures. Some more examples of what we've experienced. During 2021, there were several storms within the Gulf. None of them were actually direct hits into Corpus Christi or into our Bay Area, but they caused significant flooding in our area. So we can only imagine what that would be like if we actually did have a direct hit on a storm. Next slide, please. So with this study, we looked at mitigation measures. The new flood maps, it's possible to identify the flood probabilities and the erosion impacts that in turn lead to the development of realistic mitigation measures and coastal protection methods. So our mitigation measures that were proposed by Mott McDonald were engineering solutions to to climate change and to relative sea level rise. So they're practical, maybe not so cost effective, but as inflation rises, they become less cost effective. But these mitigation measures are such as shoreline protection, infilling low-lying property, elevating structures, revetments, living shorelines, and raising of bulkheads. Next slide, please. One of the things, given our location and the industrial expansion that we have, is the impact of ship wakes. So the ship traffic compounds the impacts that are experienced by relative sea level rise. As we saw earlier, IOB is in the bullseye of industrial expansion in San Patricio County. Not only has the ship traffic increased through the Corpus Christi ship channel to the inner harbor, the number of facilities along the La Quinta Channel has grown and is expected to keep growing over the next 10 to 20 years. Cheniere alone will double the number of very large LNG ships that cruise very close to our community over the next 2 years as they complete their expansion that's currently under construction. These very large ships cause coastal erosion. They undermine bulkheads and seawalls. They also create a loss of seagrasses due from the prop wash from docking operations. And you'll hear more about this in a little bit later in the presentation from Patrick. Next slide, please. So relative sea level rise and the preliminary projections determine that the flooding along Ingleside on the Bay will become more frequent and more severe and will impact more of the properties as time passes if no action is taken. For the purposes of this study, the intermediate scenario was selected and the sea level rise value for the sea level rise values. The analysis was performed with all available water data at the site and for water levels exclusively during September and October, as the highest water levels primarily occurred during these months. The NOAA Port Aransas gauge was used for the analysis, as it is the station with the longest data record in the vicinity of the project. So there used to be and I think we do have another data site at the pier off of Enbridge, but that was knocked out, I think, during Harvey, and it is now back up and running. But so that's good to know. It has more current data, and that's actually really close to our community. The results, though, they show a very little difference in the return periods between the completed data set of September and October. For comparison, the reported water levels in Port Aransas reached an elevated level of 6.3 feet during Hurricane Harvey. So in 2004, if you'd forward the slide, please. In the 2040, you see the increase is to be 3.9 feet above NAVD 88, which is a 1 foot sea level rise. And you see the inundation that would create within our community. Next slide, please. So 100-year flood event by 2100, the intermediate increase shows a 6.9 foot inundation level. And this is mean sea level. So this is not what would happen with a storm or with a shipwreck, and the community is pretty much flooded in all of the areas that are currently in the flood zone. Next slide, please.
Yeah, so by the year 2100, we'd have to change the name to Ingleside in the Bay instead of on the Bay, based on the current sea level trends. I was very interested in looking at Rockport, and unfortunately, the yellow line is not on the middle markers there, but you can see with your mind's eye how the increase in sea level, relative sea level in Rockport has occurred over the last 12, 14 years. And my concern, one of the questions I have, is that they've deepened the ship channel, the Corpus Christi ship channel, from 45 to 54 feet. So in essence, you have a larger fire hose feeding from the Gulf of Mexico into our bay system. Now, the positive thing would be that would have better water exchange. Yes, probably. But what happens during storm surge and with relative sea level rise? What is the combined significance of that? And I think this is really a question that needs to be looked at very hard. If you go to the next slide, they have the port was trying to deepen the ship channel in Harbor Island to 80 feet. And so you talk about almost twice the size of the fire hose from 45 to 80 feet. They'd have to dredge a channel out 12 to 13 miles offshore. They would bring this channel all the way into Harbor Island, past the ferries where large crude carriers would be loading their product. It's a very short-sighted view, in my opinion. Even being in the oil business, it does not make sense, and especially in light of relative sea level. On the left is the Mott-McDonald study that looked like it was in 2020, and you can see on the top left that's 3 meters after 2100 or so. We could reach over 3 meters based on the different projections, being the higher, intermediate, or whatever you wanted to do, any way you wanted to measure it. What was interesting to me is when the Corps presented their deepening model, it looked very similar to the NOAA model, but notice how it was about the same year, 2020, maybe 2021, but the lines of deviation of the intermediate to low intermediate were all combined. It was all lessened. And to me, as my famous mentor, Owen Hopkins, told me, be a skeptic. What are they trying to tell us here? Are they really using the right data? What are we trying to understand? Are they trying to denature the true risk on deepening this channel? So that's a question for y'all. Next slide, please. So this is the tide gauge in Ingleside. Here's a tide gauge in Aransas Pass. And I was interested in the variation between the dashed line, which I believe is let me see if I can read that. It's the persistence model, and then the tide water, and then the actual water level is the black lines. And so as you can see, the dashed blue line and the actual line deviate as you go from a moon phase, which was just this week or last week, to the slack tide on the far left in the Ingleside gauge. What's also important to Ingleside and to erosion along the ship channel are these little spikes in this data, and that represents ship traffic. And we can document that with our phones or whatever we can see. In Aransas Pass, you have actually more spikes. So I don't really know where this tide gauge is located, but you see the same deviation from the dashed line to the actual measurements. But as you go toward the slack tide, it's not the same as Ingleside. So what's causing those effects? Is this because the ship channel's already deepened? And does the larger an increase in ship traffic, how does that affect tidal flow? And will this data, how is it concerning for IOB with these ship traffics on top of nuisance tides? What kind of erosion and impacts will we have? And really, how does it affect Corpus Christi Bay? We need to understand what this means, because if they try to go from 54 to 80 feet and we don't have this answer, we have now new data. This new data ought to be able to be utilized to hopefully project and predict what we can experience, not just for tides, but perhaps in storm surges. Next, please. So Jennifer, this is you.
Unmute. So one of the other things that Ingleside on the Bay Coastal Watch is looking at is the quality of the air that we breathe. And so we started an air monitoring study with the help of Dave Felix and Dr. Coffin. It had begun a couple of years earlier with just a few monitors located in Portland and Port Aransas. And so in 2021, we received a grant to expand this air monitoring to 4 additional locations, and with Ingleside on the Bay as well. So we have currently 8 monitors that are that range from Hillcrest and Corpus Christi to Port Aransas, Ingleside on the Bay, Gregory, Portland, and closer towards Taft. And one of the reasons why this is so important is because the TCEQ has 0 air monitors in San Patricio County, which San Patricio County, as we saw earlier, is really the place where so much of this industrial expansion is currently happening and has happened. Forward, please. The 8 pollutant source monitoring monitors that are part of this this monitoring give us a good overview of what's going on, and they're combined with 2 weather stations, that one at Hillcrest and one at Ingleside on the Bay. And the hope is to be able to really determine the source of the pollution that we're picking up on these monitors, combined with the air data. And so the data that we're picking up is reviewed by Dr. Felix and his grad student, Yishi. And we receive the reports from them monthly. We also have all of the raw data that these monitors are picking up as well. So the original monitors were placed in at the end of 2020, 2021. So we have data going back to those dates up until present. And forward, please. So combined with these pollution source monitors, we also are working to determine the anthropogenic sources of methane and H2S with work from Dr. Coffin and How You. And so these are being studied in a location in Ingleside on the Bay. They're using a stable isotope analysis and greenhouse gas analyzers. And there's some very interesting results that are being found within this data. And we'll go through, see a few examples in a little bit. The 2 weather stations, forward, please. I mentioned earlier, they're also combined with a grant from the University of Texas in Arlington to create a real-time community dashboard of this data that we're picking up from our monitors. Forward, please. The forward, please. Sorry. So we've also developed a calibration protocol to make sure that the data that we're getting from our monitors is accurate. They are calibrated from a federal equivalent monitor for 10 days every 3 months, based upon the recommendations of the manufacturer and the scientific community. So we feel like our data is as good as we can get it from a community science standpoint. Next slide, please. So we use the data to compare from what's happening in certain places of our within our community. You can compare what the readings are in Port-Aransas to what you're getting from Hillcrest to what you're getting in Gregory, and combine that with the weather data to get a really good picture of what the sources are for the readings. Next slide, please. So this is a view of some of the data that we're receiving from the monitor. On the left, what you see is literally just a straight download from one of the monitors that's going to provide a snapshot of every 2 minutes, providing live data of NO2, ozone, VOCs, PM 2.5 and PM 10, and SO2. So those are the 5 pollutant levels that we're monitoring. The VOCs is not speciated, it's an aggregate. On the right, what you'll see is some of the information that's provided to us from How You regarding what she's seeing within the methane and carbon dioxide greenhouse gas analyzers, and combined with the wind direction that you see right below that, we can see by the location of the monitor during this spike that you're seeing here on April 15th. This was just a recent that this spike that occurred about 4:30 in the morning came from the south, based upon the wind direction that you're seeing in the blue on the chart right below it. Located directly south of Ingleside on the Bay is the Enbridge export terminal. And so we believe this this spike would probably coincide with a docking or a loading of one of those VLCC, very large crude carrier tankers. Next slide, please. So one of the other interesting things that we've been noticing within the data that we've collected is, so what we've received is noticing the not so small differences in the VOC measurements. And this is from August of 2022. And it's just, an interesting fact that what you see in VOCs in areas that are highly correlated to the location of industry, such as Gregory and Hillcrest, are the VOC levels within those communities compared to areas that are farther away from these industrial locations, such as Port-Aransas is probably, one of the, they're within that seaside community. They don't have a lot of industry close by, but those, so their VOC levels being, down into the 10 to 12 part per billion. And then in Ingleside on the Bay, where we have some close industrial neighbors, but we're not completely surrounded, such as Gregory and Hillcrest. So we're seeing 33,000 parts per billion, where Gregory and Hillcrest are seeing, 55 parts per billion and, 65,000, parts per billion. I mean, it's just such a huge disparity in these communities. We also see in Ingleside on the Bay some really large PM 2.5 readings during certain operations and weather patterns, which is 2.5, as many people know, is the new, really what the EPA is very concerned about regarding public health. And so we've been watching these numbers pretty closely. We see spikes above the annual mean and the recommended exposure limits, where the aggregate does not, the 24-hour levels do not pass the EPA recommended exposures, but for certain hours and 8-hour periods of the day, they do. So it kind of depends on how you look at the science and how you look at the graphs. If you aggregate it over very long periods of time, things will look okay. But when you look at specific periods of time, you realize that things in these areas are not really, as the levels are not as low as they're appearing. Next slide, please. Think maybe push it again. Can we get to the next slide?
Lost your audio, Jennifer?
I guess, can you not hear me?
I can hear you.
I can hear you.
Uh-oh.
Maybe they lost all.
And running out of daylight time too. I don't
Okay.
know, maybe she can restart us. I don't know. Audrey says we have a couple more minutes, so that's, maybe we ran out of our.
Coming in from another laptop. Can you hear me? We lost audio on our side in the conference room.
Okay, sorry.
Okay.
Okay, sorry. If you can give us just 1 second.
Yeah, well, I think we're running out of time, so we're gonna have to
I'll just skip through this one. Okay. Because the seagrass stuff is the most interesting.
all of this interesting. We can re-show it, or they can have it too, probably in a if anybody wanted to look at it, they could still access it probably.
That would be awesome. It seems like our video and our audio has paused for the moment. I'm sure that we can move around our coffee break. But we're hoping to get back on in a couple of seconds. I apologize for that.
No problem. Thank you.
Thank you.
Patrick,
I'm here.
okay, sorry about that. Zoom cut out on the presentation laptop.
Okay, should we begin? Are y'all ready for us?
Okay, I think we're good to go again.
Okay, Jennifer, go ahead.
Okay, can you go ahead and forward to the next slide? Okay, and I'm just going to do this one real quick. I know we're running out of time. So this is recent data from our April report, and this is showing several 8-hour ozone violations all over the coastal band. And so when we see results from like this, it's very interesting, and we'd like to see, really what I know that Corpus Christi has monitors, and so to compare that data that we're getting and to see if this is a transport ozone and what other pollutant levels, if the are elevated at the same time or are preceding, these spikes that we're seeing. So I'm gonna go ahead and close out our air monitoring and just let you know that, we have all of this data from these last couple of years regarding methane and pollutant source monitoring that we'd really like to use in more constructive and expand the knowledge and analysis of this data. Next slide, please. Patrick.
Oh, we keep going unless you want to. This is just more, the greenhouse gas is showing some of the methane as you fly over the Cheniere area. But we're going to go to the seagrass study here. Keep going your slide. One more. So this is a study that was done by Dr. Kirk Camerata and students. Incredible information here. This is showing some of the docking at Enbridge. The two reference points show where we're going to be coming back to with different angles. This was once a very thriving seagrass meadow, and it's changed dramatically in just a couple of years. That's docking, and that's the tugboats. They're kicking up the silt plumes that are being pushed by the velocity of the propellers across the seagrass. Next slide. Thank you. This is what Bel Air did on assessment before they want to build this next pier, 1,000 feet closest to Ingleside on the Bay. This is what they're documenting. You can see the seagrass, and they document it by each core sample. And this was done in 2020. Next slide. Dr. Camerata was out there, and this study began let me see what's the date. I can't read that. I guess in 2021, so something like 6 months later. And you can see the dramatic loss of seagrass, and you can see this silt on top of the seagrass, and you're seeing little hints of the seagrass are trying to poke their heads through, and you're seeing striations of the currents as it goes longshore from this docking operations. Next slide, please. This is just another time snap 9 months later, and you can see that the seagrass is basically gone all the way across this meadow. Next slide, please. This is an incredible sunlight monitoring, light penetration data, and it shows in the blue where sunlight was, of course, not there at night to the left. And as you get into the daylight, you're seeing the sunlight, and all of a sudden you see this drop. The drop was from the top slide. That's from a docking or undocking operation. The next drop is when the ship was being docked, where it's kicking up more silt, and the silt goes to, the sunlight goes to zero. I mean, this is a direct smoking silt gun, if there is such a thing, showing that you can associate the ship traffic and the loss of seagrass. Next slide, please. So this top right slide is in 2008. That's what the Meadows used to look like. That was a great fishing area. And if you look at what the last study was looked at in 2021, there's basically no grass there. So I guess the question is, what is the rate of seagrass loss in the coastal bend? I heard it at one point in one study that it was a tremendous amount. And we're seeing it happen within a year's time. You're seeing an incredible loss of seagrass. Also, what is dredging and what's a siltation? How does that affect the seagrasses along the ship channel? And what are the projected loss of seagrass? And what is the marine life productivity loss in the Corpus Christi Bay? Once you lose seagrass, these fish, these larvae, they have no other place to go, especially if you're losing more. Now, if you're building up these beneficial use islands, that's still a great idea if it works. I have some problems with some of that. If you go to the next slide, this is an aerial photo. Next slide shows Redfish Bay, the scientific area. And this is an island that they were building out in front of this area. You can see the silt plumes carry across the seagrass area. In actuality, this plume carried 5 miles toward Aransas Pass. And it's still occurring as far as people that fish in this area today. So it's a temporary loss, they say, and that's what the Corps is claiming. But what is temporary? Because I see the little spoil islands across the ship channel there to the south. When they have any kind of a rain event, they're still leaching out a lot of this silt. And lastly, if there's a geologist or sedimentologist in the audience, I took a hard look at the deepening of the ship channel in the Harbor Island, 80 foot, and I could not find one core that was in the poorly sorted sand interval. And yet they claim that all these cores are poorly sorted. They're really silty sands, silty clay sands, and they are a lot less sandy than what they're claiming. So as a skeptic, I really want them to understand, what does this mean long term? I think this is another issue that we need to talk about and look at. Next slide, please. So here are some questions for y'all. How does the channel modifications impact the water level and tidal variations? We talked about going from 45 to 54, and there's all kind of modeling. There's a lot of data out there, and that would be, I think, a very important part of what's going to happen. Aransas Pass, Rockport, all the whole coastal communities here. And then Jennifer did a great job on showing what the air emissions are. How is that going to impact all these different communities as these industries spring up and as amended air permits are getting increased over time, with the agencies not restricting them, not having any penalties or of the violations that they're committing. And so we need to have this data integrated where we can find ways of finding the source, having the TCEQ or the EPA put up other monitors that we can actually measure the damage that we're experiencing in our lungs. And then how does seagrass, what's going to happen to our seagrass? What's the degradational impact? What's the aquatic life productivity? How's the ship traffic going to affect it with relative sea level? Next, please. And thank you very much. Here's some of the studies that we'll supply for y'all. We have a lot of information, too much information to go over in a short period of time. And myself and Jennifer, thank y'all for your time and listening to our questions and issues. Next.
Okay, our next presenter is Christina Lopez from the Meadows Center for Water and the Environment. And Christina, you should be able to screen share. There you go.
All right. Hello, everyone. How are you? I waved. That's awesome. Thank you. Can you see my presentation? Thumbs up. Perfect. Oh, hold on. I have got two screens and one of them is showing up as the wrong monitor. Fix that real quick. All right, there we go. All right, thank you so much for inviting me. I feel very honored and excited to participate in this program and workshop. So what I plan to do today is give a brief overview of what we do at the Meadows Center, and then I'm just going to be sprinkling in some potential research questions or needs. My name is Christina Lopez, by the way. I am the coastal coordinator at the Meadows Center for Water and the Environment. I manage all of our coastal programs, and I also teach geography in the Department of Geography and Environmental Studies. So a little bit about who we are, if you don't know. We are a research institute at Texas State University. We're on campus, but we're a little bit outside of the main campus. So we're right on Spring Lake, which is the headwaters of the San Marcos River. We have a pretty big mission. It's inspiring research and innovation and leadership that ensures clean, abundant water for the environment and all humanity. So with that, the Meadows Center has 4 major pillars of work, and the first one is around research. We also do education. As I mentioned, we're here on Spring Lake, the headwaters of the San Marcos. We have the historic glass bottom boats. We do lots of field trips and just education for the general public as well. We also focused on stewardship and leadership, but today I'm going to focus on our research. So we have some major goals and objectives around research at the Meadows Center, and basically we seek to do applied research around addressing real-world problems. And we seek to address problems around water challenges, of course, Meadows Center for Water and the Environment. And then our research also seeks to improve our understanding of complex natural and human and water systems and kind of the nexus of all of those different components. And with that, we hope to promote the sustainable management of water. Now, I'm in the Department of Watershed Services, but I wanted to give a brief overview of some of our work. So in Watershed Services, we have Texas Stream Team, which is a community science program. Texas Stream Team has trained over 12,000 community scientists over the 30 years that they've been in existence. You can imagine we have a lot of data. We have over 400 community scientists that monitor in a location monthly, and the locations are across the state of Texas. So it's a pretty big program. We have a lot of community partners and local monitoring groups that do that as well. And then out of Watershed Services, we also manage Clean Coast Texas, and I'll talk more about that in a minute. We also work within the Clean Rivers Program framework. We do professional water quality monitoring in the Hill Country area. And then our staff also support local watershed protection planning in this area. And then we do a whole lot more, so it's just a little sample. We have a new climate science director who just joined us this year, and she's going to be developing a climate science program at the Meadows Center. We also have a new hydrogeologist who joined us recently, and he focuses a lot on groundwater modeling and understanding surface and groundwater interactions and more, of course. And then, as I already mentioned, we have a lot of environmental education happening here with Spring Lake. There's also been some research around understanding how children map and experience their world and their environment. And then there's also research done here on place-based pedagogy and a lot more. So to highlight some of our coastal work that we do, I already mentioned Clean Coast Texas, but what that is the Clean Coast Texas Collaborative. So it's actually a program of the General Land Office, and it's managed by the Meadows Center. That's my primary job here as the coastal coordinator. So we work with several different entities that are pictured here on your screen, and we seek to help coastal communities expand their capacity, specifically around stormwater management, using green infrastructure and nature-based solutions. Some of our other coastal work is expanding Texas Stream Team to coastal communities. We're also looking to expand the types of monitoring that Texas Stream Team does in coastal communities, such as monitoring for coastal bacteria. And also we have some advanced trainings that go beyond just the basic core parameters that most of our Texas Stream Team community scientists do. And then we also are developing some social science components to the coastal work as well. So I know that y'all are thinking about end users, so I wanted to share how we view our end users at the Meadows Center. So of course, with our coastal work, our coastal communities are the end users of that. We also have the general public, especially with our environmental education component. Other non-governmental organizations, we partner a lot with other research institutions and other nonprofits. And then cities, counties, and state agencies. So with the Clean Rivers program, that's under TCEQ. The watershed protection programming that we do is mostly with the city of San Marcos, where we are located. All right, now getting into some research opportunities. So there's been quite a few studies on Texas Stream Team. I personally did a research study on the motivations for participating in Texas Stream Team and other types of environmental stewardship programs for my PhD that I completed about 2 years ago. Right now, we have a study where we're looking at the qualitative experiences of participations in Texas Stream Team. So we've done a survey and we're conducting interviews on that right now. But for potential research, we have some ideas around using AI to review historical data. As I mentioned, this is a over 30-year-old program, so we do have lots of data around that. And we are happy to entertain any other ideas with the data. Our major goal is to have that data be useful to our end users. So some other ideas are to compare with TCEQ data of the Clean Rivers program and possibly predict trends in water quality with full build out. And then we could also couple the Stream Team data and other forms of data with Beach Watch data. With Clean Coast Texas, we work very closely with the General Land Office, and we do have their go-ahead to say that we can offer Beach Watch data through this program. So these are some general research ideas that we have around our Stream Team data. Some other general interests that we have at the Meadows Center are possibly AI to influence and improve pro-environment behaviors. We would also really like to understand the impacts of stormwater ordinances and other non-point source pollution measures on water quality outcomes for the coastal communities. We're also really interested in perceptions of sea level rise and applications of community decision-making on the Texas coast as well. And then again, some other just general interest, maybe how social media can alter environmental perceptions. We have ideas around removal of lawns for water conservation. That's a huge thing in our area of the Texas Hill Country. Maybe even looking into TikTok applications or native talk where people promote removing lawns and planting native vegetation instead. And then another idea is around effluent or the discharge that comes from treated wastewater and how that can affect coastal communities. A lot of our work with Clean Coast Texas focuses on the Little Bay Restoration Initiative in Rockport. And so we're wondering how, dilution is the solution to pollution till what point maybe. And then also align with our hill country and coastal work is we're interested in migration patterns and how people may or may not be moving to the hill country or to the coast, or also how an influx of migration to the hill country might affect environmental water flows to the coast and how that could affect water quality for our bays and estuaries and coastline. So at the Meadows Center, we collaborate across Texas state. We have very strong relationships with biology, geography, and more. And these collaborations allow us to expand our end users. And we also have a focus on student research. Undergraduate and graduate student research is really important to us at Meadows. Here's one example of how we collaborate. So we have Dr. Jesse Backstrom. He is one of our, collaborators. He's an assistant professor of applied economics. And he threw out some research ideas that he has, and there are three major interests that he wanted to share with us, to share with you all. And the first one is around fisheries. He would like to understand the social cost of climate-induced events on commercial and or recreational fisheries in the Gulf of Mexico. And this idea is an expansion of his dissertation research. He also has ideas around water related, so efficient and inefficient groundwater management in Texas. And this goes back to the Meadows Center kind of broad research interest on how migration in the hill country, we do use groundwater for irrigation and municipal and other types of purposes, how that might affect environmental flows down the coast. The second one is very similar, so the effects of industrial development and land use on groundwater quality in Texas and effects again on coastal water quality. So we're trying to look at large scale systems here of human consumption and environmental flows and how that is going to affect water quality in the long term. So maybe, you know, in the next 50 years or so. Also questions around oil and gas. So how might the effects of groundwater conservation districts on oil and gas development in Texas, and quantifying emissions from oil and gas activities. I caught the tail end of Ingleside on the Bay. I don't know if maybe that's a little similar to what y'all are doing. And then oil and gas wastewater disposal in Texas. And then there are some ideas for data sources around these interests. All right, so that was just a quick overview of what we're about and some of our broad research ideas. And I'm open to any questions or comments at this time. Any questions? And with this kind of broad overview, we're very happy to unpack any of these interests that you may have maybe in the next session or tomorrow. So feel free to reach out anytime. I'm sure that Dr. Douglas has my email she can share with you all.
Did just start pouring here, so we're all kind of craning to look outside at how heavy. Will you be available for the Q&A later today?
I believe so. Could you please remind me what time?
2 o'clock.
I think so, and if not, I will send representative.
Okay,
Thank you.
it's gonna be the same Zoom link.
Okay, great. Thank you.
Thank you.
I'll ask a question.
But we do have one question.
Sure.
Thanks for your presentation. Do you have something in mind with the text speech watch? So you want to couple some river inflow or other, and then explain text speech watch data further along our coast?
Yeah, so I am personally not super familiar with the Texas Beach Watch data, but I know that they do collect the bacteria across the coast. And it would be interesting to couple that with maybe groundwater data to see if that has any sort of impact on that. And then also looking at the data that Texas Stream Team collects, which is across the state and on the coast. Now we do collect just the core water quality parameters like pH, temperature, conductivity, dissolved oxygen, and things like that. So I'm not sure if I'm answering your question because I don't think that I heard you correctly.
No, I wanted a bigger picture of where you think the modeling could go on. So that's great. So
Okay, yeah, I think that there are a lot of opportunities, and we're open to basically anything that y'all might find interesting or useful. We do think that there's a lot that could be done. We just don't have the capacity to do it in-house ourselves right now.
Thank you.
Thank you.
One more question.
Thank you. Thank you so much for your presentation this morning. We do appreciate you
being present here. I am curious on some of the social surveys that you were trying to conduct with the stream team. Can you talk a little bit more about that, how you're utilizing that within some of your more quantitative data sets rather than qualitative?
Sure. Well, the current study that we're doing, we did a very brief survey. It was like 10 questions, all open-ended, which led into the interviews. So there's that piece. And then the research that I did 2 years ago was more of a quantitative, closed-ended survey that was really focused on understanding the motivations and the outcomes of the citizen or community scientist for Texas Stream Team. So right now, those two studies aren't really speaking to each other, but they could. Like I said, we're still collecting interviews right now, and we're just basically trying to understand the more general qualitative experience of participating in our program. But since you mentioned the social science, I'll point out I did not put this on the slideshow, is that I'm doing a study of absentee landowners in Texas, focusing on 5 watersheds that have watershed protection plans. And I'm doing a quantitative study on that. I'm trying to understand the motivations for owning the land, what they do with the land, what, if any, conservation practices are in place, how the absentee landowners like to receive communication about their land, and if they are aware of any watershed protection plans in their area. So that's just another example of what I mean by, like, we're expanding the social science part of it too.
I think that's pretty awesome. I really do appreciate it. Maybe I can pick your brain later on in Q&A if you still have some availability. But I do believe that there's a higher emphasis being projected right now on the importance of bringing in qualitative and quantitative methods to really understand the deeper perception and motivation of why and how our community can get more embedded in some of the environmental degradation issues that we're seeing along the coastal system. So I do appreciate that. Thank you.
Thank you. Yeah, absolutely. Happy to unpack that further and chat anytime.
Okay, in Zoom, we have a comment from Catherine Maston from Ingleside on the Bay. And she says that Ingleside on the Bay is part of the Clean Coast Texas Initiative and will soon be participating in Stream Team. We're also very interested in the bigger oil and gas emissions idea, since IOB is very much impacted by all of this industrial development.
Yes, as Clean Coast Texas, we are super excited to be working with Ingleside on the Bay. Super excited to see them in this call too.
Okay, so with that, it's time for a 15-minute break. So reconvene at 11.
And go do this to clear out stuff. Right? Yeah.
But I don't know how they do that, other than paying like right, boys, right. So it needs to be. And then 12 days. Okay, but it can be a little long. But that's something we're like. Right, so does that happen? That is great, that's a 90-degree coming off. Okay. Okay, all right. All right, and then probably goes up above the where it's below. Yeah. The reason I'm asking, you know, I do have folks on the trail down there, so they have everything, and they're pretty good at the plan. I'll be go over there and say, and then and basically we're just lag holding it on to the wood. Okay. All right. Okay. Cool. Yeah. So that's probably a little more than 6 inch gas. So maybe 8 on the place. Okay. All right. Well, for the other day. I may go and see. And then you want a 4x60 or is that 4x? Okay. Probably get an 8-footer, drop it to the bottom, roll it in, and then we'll put it wherever you want to put. You know, I'd rather have it too high than not high. And we can run one line. And then once it's on here, this thing to be thin, so this is Yeah, absolutely. And that's what we're gonna increase. That's my water treat, not on the road, but yeah, then yeah. Twitter, I don't like that. That's the one I'm just gonna throw it up. Right. Yeah. Yeah, and if you find something, let me know. And if you can't find something, I'll run up. Right, yeah, that's honestly. All right. That's
Are you going to be at the Tony?
It's got the mic.
I've got the mic and I'm just figuring that out.
That's great. That's a good idea. That's a good idea with the.
Oh, okay.
We'll see if we'll play.
Yeah, exactly.
Okay, if everybody can start making their way back to their seats. Our next presenter is the Calhoun County Extension Agent, RJ Shelly.
Good morning. It's a pleasure to be here. I don't have a lot of data, but we do use the products, some of the products that you all do. So I thought I'd just give you a little brief introduction. My name is RJ Shelly. I am the Coastal and Marine Resources Extension Agent for Calhoun County. There is 7 Coastal and Marine Resource Extension Agents in Texas. 6 of the positions are filled now. We're in the process of trying to fill the one in Matagorda County. We actually work for 3 different entities. So the extension agents, the coastal marine agents, they get 1 check a month from Texas A&M. It is split between Texas Sea Grant and Texas A&M AgriLife Extension. And then we get a couple checks a month from the county. So the county has to buy into our salary. And the purpose in the extension system is Texas A&M is a land grant, sea grant, space grant university. And we are supposed to take the research and the knowledge gained by the system to the field, to the actual stakeholders. There is extension agents in all 254 counties in the state of Texas. We do not have extension agents in all 13 coastal counties, but we do have actually 8 of them covered. One over in East Texas, Nikki Fitzgerald, she splits her time between 2 counties on the Louisiana border. So the way that we are supposed to stay in contact with what the local community needs, of course, we work for the county judge. We work with elected officials quite closely, both on the county level, but then also with some state reps and state senators if it's needed. And we have to form a committee, and the committee is supposed to steer what we do. So for instance, in my committee in Calhoun County, I have a Marine Advisory Committee. If you all have ever been to Calhoun County, it is a peninsula. It is surrounded by water on 3 sides. So I have a representative that's the executive director of the Matagorda Bay Foundation. I've got the chairman for the San Antonio Bay Partnership, the vice president of the Lavaca Bay Foundation, the lower basin person from the Guadalupe Blanco River Authority, the operations manager for the Lavaca Navidad River Authority, the city manager of Port Lavaca, the harbor manager or harbor master of Port Lavaca, and the executive director of the Calhoun County YMCA. The goal is to have a pretty good cross section of the community so that we can determine what the community needs and act on it. Part of the reason that committee was put together, it's up to the individual extension agent as to who they want to invite to the committee. Some of the ag agents committees are longstanding, but not necessarily a marine. I worked managing the oyster fishery for the state health department for 25 years before I came to extension. I handled mesquite bait of the San Bernard River out of Port Lavaca. Prior to that, I worked for Parks and Wildlife Coastal Fisheries Office in Port O'Connor. So I've been in the county for a long time, and I knew who worked for what organization and what they could and couldn't do when I took this position. I came into this position as a rehire. I was a retire from the ERS system, coming to work for the Texas A&M system. I did not have to wait. It was immediate into the TRS system. So I was on the job for 6 weeks and I get a phone call from a lady in the county and she's like, we may win some money in a lawsuit. And lo and behold, they did. And so I've been involved in a lot of the Matagorda Bay Mitigation Trust projects in the county from the beginning. And so when this committee was put together, a lot of the mid-coast counties, they get forgotten. You know, if you look at where a lot of the state and federal funding goes, it goes to Galveston, it comes to Corpus. A lot of the small counties have been left out in the past for the most part. So we got the group together, and in the first meeting, which was in December of 2019, we decided we can either work together and keep some of this money in the local area, or you can compete against each other for it and you can watch it go somewhere else. The group decided to work together, and so far since 2019 December, they individually, the group has total bought in a little over $2 million to stay in the county to do those projects. That's where we get some local stakeholder input, and then working pretty closely with the commissioner's court, we know what they need. So I was at UTMSI last year at the Texas Basin Estuaries meeting, and I watched Dr. Tussaud give a presentation on some of his water level stuff. It was looking at inundation on Padre Island. And he sat down next to me when he was done. And I mean, my head was already spinning. I was like, can you reproduce this up the coast? And he said, yes. And so the issue that we have is Calhoun County has a low-lying shoreline around the Indianola, Magnolia Beach area. If you've all ever studied the history about the Indianola hurricanes, that area is subsiding. The sea level rise is coming up to it. Several of the students have been up there. I think I've got to show them the courthouse, which is now currently the old foundation. It's in Lavaca Bay by about 50, 60 feet. It's out in the water. So we have an issue on Ocean Drive, which runs along the shoreline of Lavaca and Matagorda Bay. And when the water level gets high, it goes over Ocean Drive in 2 spots, and it cuts off some homes. And it's a public safety issue, because a lot of times when your water level's elevated, it comes up overnight. Now it's dark. People will drive into it if they don't know any better. First responders can't get to somebody having a medical emergency. It creates all sorts of problems. The commissioner in that precinct will send his crew out when they know it's going to be high, and they will barricade the roads. And then they will call into the EMS dispatch center, and they will alert the deputies and the EMTs that road is not passable. So if you catch it before it happens, you can save a life. If you don't, somebody can drive off into high water and get swept away. So I asked, would it be possible? Dr. So came up, Miranda came up, and I talked to my judge, and I've been to some other presentations in my time with Extension, and somebody said it best at a prescribed burn school. She said, in Texas, there's God and the county judge, because the county judge has a lot of power in Texas, and they are the ones that can call for an evacuation. But when they call for an evacuation and the event does not happen, they catch a lot of flack. So after listening to the presentation during the Basin Estuaries meeting and talking to Dr. Tussaud, I talked to my judge and I said, what if somebody could produce something that would let you know with a high degree of accuracy that that road was going to go underwater overnight. And I said, would you be interested? And his words were, see if you can get him here. So we did, been up a couple times, and that's the main project. We're looking at water levels. We're looking at Ocean Drive because it has a population that's low income. They get cut off during high water, and it can be dangerous for the first responders to get to them. And some of the communities, this happens up and down the whole coast. AgriLife Extension puts on the Judges and Commissioners Conference for District 11 every year. That's where they get their CEUs. I've been there. We've done some marine infrastructure funding programs for them. You know, they tell us what they need. We give it to them. I saw the potential for what you're doing here to help them, and I reached out to ask for help. And that's why I'm here. But what we might be able to do for you, whatever project you're looking at, really wherever you're looking at it in the state of Texas, if you all are trying to get a good grip on local stakeholders and know what they need, what they want, what their limitations are, you may be able to reach out to the extension agent and get that information, and they could help you identify the problem. They can run interference for you with the local elected officials if you need something done. Sometimes, because we have a fairly close relationship with those officials, we know what a particular official's likes and dislikes are and what their needs are, and we might be able to phrase it once we understand what you're trying to do in a way that is more conducive for them to accept it. The other reason, or the other thing that the Coastal Marine Resource Agents do, the 7 of us are locked to AgriLife Extension. We are not locked to Sea Grant. We work underneath Sea Grant. I answer to the director of Sea Grant. I answer to the head of Extension, and I answer to the county judge. But because I am locked to AgriLife Extension, when we have a project that's going out, or we see the real benefit for grant funds to go to something, we can walk in the door of your state senator's office and try to get that letter of support you might need, or the state rep or the county judge. And we can use those contacts that we have, and it is legal. So whereas like on the Sea Grant side, Sea Grant won't do that, but I can put a different hat on that day and do it. So I just want to kind of give you a little brief idea of what the extension agents do. They are pretty well connected with the community as far as what resources the community has, and mainly what problems they have. And we do that through not only the committees, but we also every 5 years we have a big event where the people in the community will come out and they'll list things that they want done as a priority. And we keep those lists going, and we have to account for, did we address that or did we not address that? We also handle a lot of education. We take some of the information that we learn from the research that you're doing, and we try to educate public school kids, teachers. We do teacher professional development. In the case of the water level issue on Ocean Drive, we found a sensor location. It just so happens to be, it needed to be in an area that was not prone to vandalism. I know that Calhoun County has a CMP grant from GLO for an educational pavilion that's going in there. I have been asked to assist the county with educational signs that have to go around that pavilion. And so while we were looking at the site, we said, hey, why don't we make one of the 6 signs AI and how it's used in natural resources? Because this will be a pavilion that we will take K through 12 students to, the public will go to it. And I do a lot of these. In fact, I'm not going to be able to be here tomorrow. I've got to do an aquatic science trip to the wetlands up in Leward with the 11th graders. But my thought was, if we have some kids that are on a school field trip that's natural resource related, and maybe there's a kid in the crowd that's not really their thing, but they love technology. Well, they may see that and then put the link together of how you could use this artificial intelligence for natural resources, and that may get the kid interested, where either they pay attention that day or they find something else that they can go into. And so I'll leave it open for any questions. There's only one thing I wanted to share with you. This kind of hit me. I was at an ag agent meeting. Sometimes because there's so few of us, they lump us in with the ag agents. And we were having to give briefings as to what we have going on. And I used the term AI with the ag agents. Like, yeah, we're going to AI. They thought I was talking about artificial insemination. So we cleared that up real quick. No, we're not artificially inseminating a heifer here. So just kind of use a little caution depending on who you're working with the acronyms. If anyone has any questions, I'd be happy to answer. I'll be around all day today, and you'll have access to my email if there's anything I can do for you. And if you ever have a project where you're working up in the Calhoun County area, feel free to call me. You know, you may want to know what boat ramp can I get out of on this tide to go here, go there. I've got a researcher that's contacted me from, I think, HRI. It was yesterday. They're looking for a couple of private piers to put some instrumentation off of. We might be able to find that landowner, make the contact, explain what it's for, and get it done. So thank you very much.
Online, Catherine Maston is asking, is there an agri-life extension agent for San Patricio County?
Yes, San Patricio County has an ag agent. They also have a 4-H agent. The newest marine agent that we bought in was Aransas County. Aransas County historically had one. They went about 16, 20 years without having one. We put one in there January this year. He came in over from the health department. He's got a specialty of oyster processing. He used to be the state standardization officer. We brought him on to help the oyster farms because they're going to need to be able to run the oysters right in the back door. He's going to help them get through the HACCP process. But he's the closest one. And we work, the Sea Grant agents work across county lines a lot. The ag agents generally not, they stay within a county, but the federal component of our funding allows us to travel up and down wherever we're needed. Yep.
But if you don't need to what kind of things whether that's 6 hours unpredictable hours, 24 hours, and what that looks like for the community that is under that kind of grace.
They'll jump up and down with 6. I mean, 6 hours would be fabulous. The way that a lot of the coastal communities, because they deal with hurricanes, their judges deal with hurricanes, we have it, and I think most of them do. There's a phone system, a call out system where the residents in that county register their phone numbers, even, you know, cells, doesn't matter. And they'll hit that list with an evacuation. It has gotten very specific where the judge can work with emergency management and call it down to a certain block or two. So in the case of the Ocean Drive, he'll home that right in. And if he knows 6 hours out in front, it's going to go underwater, he'll send the phone call out. You know, that way, at least if someone's on oxygen, they'll know you better make sure your bottle's full, because if the power goes out, they can't get to you. So. Thank you very much.
Okay, our next presenter today is Penny Harness from the National Weather Service here in Corpus Christi. And Penny, you should be able to share your screen.
All right, do you see that?
Yes.
Okay, great. All right, good morning, everyone. Apologize if I get distracted. It's raining pretty hard out my window right now, and it's kind of my thing. So I am with the National Weather Service here in Corpus Christi, Texas. I'm going to talk a little bit about what we do if you're not familiar with it, and then we'll talk about some challenges that we have. If I can get my slides changed, there we go. So there are 122 National Weather Service offices across the country. In Texas, there are approximately 9 offices that cover at least part of Texas. And then across the country, most states have a couple of offices. There are 13 river forecast centers, and there are also 9, and I think this map needs to be updated to a 10th national center in the country. We've got the Storm Prediction Center, the Hurricane Center, the Aviation Weather Center, the Water Center, several national centers as well, and they all do different things. So the mission of the National Weather Service is to provide weather, water, and climate data, forecasts, warnings, and impact-based decision support services for the protection of life and property and enhancement of the national economy. So our job is to save lives, save your property, but save lives is our big thing. This is the area that our office covers here in South Texas. We go from Victoria to Kingsville to Laredo, essentially. Cotulla is our northwest corner. So we have 15 counties, and then we have waters out to 60 nautical miles. So we've got the bays and then the waters from Matagorda Bay to Baffin Bay, out 60 nautical miles. In our office, we have approximately 22 folks. That first box is management. We have a meteorologist in charge. He's our boss. Then we have the warning coordination meteorologist. That person interacts with the EMs and the public a lot. We have the science and operations officer who does a lot of training. And Tim Humphrey is actually the main guy in this project, but he's not available today. So I am filling in. He's our science operations officer, and you will meet him tomorrow. We have an electronic systems analyst. We have an IT officer. Well, we don't right now because ours left last year. We haven't been able to fill that yet. We have an administrative assistant. And then in the forecasters, we have 5 lead forecasters. We have 8 general forecasters. I'm one of the lead forecasters here. We have an observation program leader who helps to make sure our observations coming in are quality controlled. And then we have 2 electronic technicians who help to keep all our systems running. So a lot of people think that all we do is do a forecast, or maybe people think, I think my husband thinks all we do is if there's severe weather, we are issuing warnings. And if there's no severe weather, it's quiet. But that is absolutely not the case. So we're doing all of these things on a daily basis. We do a 7-day public forecast of temperature, dew point, whether it's going to rain or not, wind, wave height, a whole bunch of things. Every day, twice a day, we're doing a 7-day public forecast. We're doing a 5-day marine forecast. We have aviation forecasts for 5 airports in South Texas. We do river flood forecasts. fire weather forecasts, and then obviously severe weather stuff and hurricanes. That includes even a wind advisory or a heat advisory or any of those like non-precipitation type hazards as well. We manage climate data. We send out climate reports every day, several times a day. And then we also have to quality control the data we're getting in, and that's going to get into a little bit of our challenges later. We launch weather balloons twice a day. Some of you maybe have seen it. I know the meteorology folks get out to see that every once in a while. And that's going to be a big part of data available to us. And then we also do decision support services, which is a part of our job that's really increasing, where we're sending sometimes daily email briefings out to our partners, especially the emergency managers. Sometimes for events, for Buck Days, we were sending emails every morning for 2 weeks that are specific to downtown Corpus Christi. We do a lot of social media posts. We hold conference calls when there's big weather coming. And we're also text messaging with our emergency management partners when there's impactful weather. So we're doing a ton of stuff every single day. It's never really quiet. Again, our severe weather watches and warnings, that's our big thing. That's what keeps us relevant. So even right now, we probably got an inch of rain outside my house here in the last 30 minutes. So we would be watching for the rainfall, issuing flash flood warnings or flood advisories, severe thunderstorm warnings, tornado warnings. It was a fairly busy weekend with some of the weather going on. And those do go to mobile devices, some of them, and weather radio. And we also do some local drills with emergency managers. Another in the decision support realm that we do is if there's some kind of event like a fire at a refinery or a chemical spill somewhere, we can run a plume model, and we also provide a site-specific forecast to those locations so they can better understand what may happen over the next several hours with who may be impacted, potentially if there's evacuations needed, something like that. So we're always there to do that. I didn't mention we are 24/7. So there's someone there all the time. It makes our schedules rotated. So like my schedule, I work one week on day shift, 1 week on afternoon shift, and then 1 week on overnight shift. So we're all rotating, taking the punches of the midnight shifts, but we're always there for our emergency managers and public when they need it. Coastal and marine forecast. So we do a general forecast, which is basically the wind and the wave heights, and then precipitation forecasts. But we also send out warnings for gale warnings or small craft advisory based on the conditions. And we do coastal flood advisories and rip current products as well, which we will touch on in some of our challenges later on. Our marine warnings start at just 34 knots or about 40-mile-per-hour winds. Our aviation forecast, again, there's 5 airports in South Texas that we do aviation forecast for, which is a challenge in itself, to be able to do cloud heights and what the winds are doing aloft and that kind of thing. Our general forecast, this is a snapshot of the program we use when we're doing our forecast, and we create grids for temperature. You see the temperature ones there, they're a daytime and a nighttime, but for other things like wind and precipitation and dew points, we're doing hourly forecasts of those conditions. And it's kind of like coloring when we're doing these. Like we just go in there and we have a pencil tool and we can just adjust the colors as we need to, and the colors associated to the values. Social media, if you follow us on social media, if you don't, I recommend it. If you do, we are doing today and tonight forecast every day on social media. If we have any kind of hazardous weather, we're putting those out on social media. We do a video briefing every day, about 1 to 1.5 minutes, that we put on social media. So we're pretty big on our social media around here. It's really the best way for us to communicate these days with the public. We emergency managers, we can communicate more closely otherwise, but the public, people aren't going to our website so much anymore. They're going to social media to see what the forecast is going to be. So our forecast process, we look at big levels. We look aloft to see what's going on the big picture, and then we gradually zone it down into a more local forecast. But we also have to make sure we're using models most of the time, but we have to make sure those models are representative in the beginning so that we know that we're starting. If it says we have 5 apples and we only have 4, we're not starting in the right place, and that's going to affect things down the road. So we want to make sure that our observations are good and we're starting at the right place when we're doing our forecast. So we'll go into some of the observations, some of the data we have available that you may be able to use in projects. I'm not going to read through each of them because we will go into them deeper. So our automated surface observation system, we call them ASOSs. They are generally at airports. They're around the country. We have 7 of them here in South Texas. These are recording constantly temperature, humidity, if it's raining or not. They measure the rain, they do wind. These are some of our biggest sources of information on current weather on a quiet day. I mean, they still are operating on busy days, but on a quiet day, we're not worried so much about the radar and the satellite and that kind of thing. And our office does maintain these ASOS sites so we can keep them quality controlled. Our upper air program, again, we launch balloons twice a day. This video here on the right that I'm going to play, I'm not sure if the audio is going to play, but the audio is not important anyway. This was a balloon launch we did during Hurricane Harvey back in 2017 with 50 to 60 mile per hour. Let's see. There we go. So I'll pause this because of the audio. So we usually do a 1-person balloon release. When the winds aren't too strong, we can easily do that with 1 person. We've got a sonde that we're holding on to that is what measures the environment, measures all the parameters as it goes up. And then the balloon you'd be holding with your other hand, release the balloon. And then when the winds are really strong, it's going to take that balloon sideways. So we have to hold on to the sonde a little bit longer, but on an easy day, it's pretty nice. And that balloon goes up 30,000 meters, I believe is our approximate height before the balloon pops. Again, it's measuring all this data. The red line on this plot here is the temperature and the green line is the dew point. To the right, those black flags are wind speeds and directions. And this data is very helpful. Like I said, we use models, but if those models are initializing incorrectly, it's not going to help. So this is a way that we can verify how the models are doing. It's really one of the only ways that we can get observations above the ground. Our ASOSs are great, but they're only going to tell us the ground information. The weather balloons are what helps us get observations aloft. And there's, I think, about 70 across the country, across the US. I think there's about 70 balloons, and then there's additional across the world. But we all launch them at the same time. And that helps to, when this data goes into the models to help initialize the new runs, that helps to make sure everything is consistent. We have a 90-minute window, but generally we're looking at this time of year, 6 a.m. and 6 p.m. to launch. I guess there's another video here. Let me play this too. Oh, no, it's sideways. Never mind, I won't play that one. So radar, which is probably one of our things that you're most familiar with. You see it on TV all the time. Some of you may have apps that show you the radar. Every office has at least one radar associated with it. Some offices have 2 radars. This is a radar loop from Hurricane Harvey. Pretty sure this is Harvey. Let's see. Yeah, 2017. So the radar is super valuable to us, and it doesn't just, what you're seeing here is reflectivity. It's telling us where the rain is, maybe how heavy the rain is, but we can also see wind speeds from the radars. The radar goes out to and measures the drops, but it can, Doppler effect, it can see how quickly those drops are moving, and in that way estimate the wind speeds in the system as well. Here's another radar loop. This one is Hannah, which some of you may remember because it was only a few years ago now instead of already 5.5 years ago for Harvey. There are 155 radars nationwide, and they're constantly operating. But they only are detecting rain and aerosol particles in the atmosphere, not necessarily what's at the ground. And by the curvature of the earth and how the beams work out west, like Laredo, the lowest scan we're seeing is a few thousand feet off the ground. They did actually, a private citizen actually put in a new radar out in Laredo last year or in the last couple of years. During severe weather, we can get scans every 1 to 2 minutes. In a quiet mode, it's more like 6 to 7 minutes. So we're letting the radar relax a little bit. It's great technology, but we also still need to be able to know what's going on the ground. And that's where our co-op network comes in. Our co-op network, and this is an old image. I know it doesn't show much over South Texas, but we do have several sites over South Texas. I just couldn't find a more recent image. I don't think they have one. So our co-op sites, we have probably about 24 of them here in South Texas. Every day, around 7 a.m. in the morning, they go out and measure if there was any rainfall. They measure how much rain occurred. And then a lot of them, not all of them, a lot of them have a temperature sensor, and that temperature sensor resets on a daily basis. And so it gives us a maximum and a minimum temperature. That also helps to know if our models and other things are performing properly. And it goes into climate data. There are a lot of rain gauges. I don't know how many rain gauges we have here in South Texas, but there are rain gauges across the country. And we're monitoring them for flooding. We had a lot of that this weekend. And with the rain that I'm seeing outside my house today, we may see some more. In the upper right, the blue line is observations from the Oso Creek here in Corpus. And the purple line is the forecast. So you can go to our website and see these graphs at any time for any site. There's not always forecast data if it's not into an action or a flood stage. Then we're just letting it ride. But that's another one of our technologies. There are buoys and tide gauges across the oceans. Unfortunately, for our area, we don't have any buoys directly in our forecast area. They're north and south. I know Dr. Tissot had a buoy just offshore here that we've had some issues getting the data from. So that was helpful for a little bit. We also have all these other marine sites. so the buoys are giving us mostly wind and wave heights and wave periods. There's other marine sites that are giving us different elements as well. Some are giving us water levels like tides, air temp, water temp, pressure, wind, relative humidity. And we've just recently in the last 2 or 3 years, thanks to the Port of Corpus Christi, and I think Dr. Tussaud's team helped with that as well. Visibility sensors, which have been very useful for us in forecasting fog in the bays. That's definitely a difficult element for us to forecast because just very small changes have a big effect there. So we have visibility sensors now, which is great within the port. We actually, I think, out of all the coastal sites here in the Gulf of Mexico, we probably have the best visibility network of anybody. And then we also have satellites. So as much as little as probably 5 to 10 years ago, we were getting satellite images every 15 to 30 minutes. With our latest satellites that launched something like 5 years ago, I can't remember now. Well, I guess it's probably been closer to 10 by now. We can get satellite images every minute or 30 seconds in a mesosector. So not the whole country, but a small area. If there's big weather going on, we can focus a mesosector on a small area. And we can get updates up to every 30 seconds, which is incredible. It really lets you see in a more fluid way what's going on in the atmosphere. And this is a mesosector that was over Hurricane Harvey. I think, now that I think about it, this was one of the first times we had mesosectors for tropical. So it may have been 2017 when we got the new satellites. So you can see how fluid that is watching the hurricane approach the land. With the 15 and 30-minute images, it was very jumpy. And this satellite that you're seeing right now is our infrared satellite, which is measuring temperatures of the clouds. So the red is the coldest, highest clouds. Grays are warmer clouds. So you can see where the eye went just over Rockport and just north of Rockport. This is a visible satellite picture. So if you were up above the earth looking down, this is what you would see with your eyes. And again, it's Hurricane Harvey. And here you can see with visible satellite, you can see it on IR too, but you can see the bubbles. Like if you look up toward Matagorda Bay, you can see, I'm sorry, that's Galveston Bay. You can see where things are bubbling. Those are like stronger updrafts and where thunderstorms are more likely. Hurricane hunters, another technology. They give us observations. They fly only when needed into hurricanes, and they're dropping kind of like the sondes that we send up from the ground. They're dropping into the storm to measure what's going on in the hurricane. And our model data that I referred to earlier, this is what we're looking at in our system. This particular one is showing some conditions at the surface at 850 millibars up, 500 millibars up, and 250 millibars up. We're looking at different levels to see different things when we're doing our forecast. And then our final product goes out in text products and graphics on the web. So some of the challenges that we face every day, and this one I'm super happy that we've got this one in here because it's relevant to me right now. Predicting the expected rainfall rates based on environmental conditions. We know it's going to rain. We know that our moisture levels are high. But what does that translate into? How fast is this rain going to fall? Because 2 inches of rain in 12 hours, not really going to affect you a whole lot. I mean, you're probably going to love 2 inches of rain in 2 hours, but 2 inches of rain in 1 hour could lead to some street flooding or other issues. And we may need to do flash flood warnings for rainfall like that. So that's one of the, so all these challenges are Tim's thoughts. I'm just passing them on. So he's going to be better to answer questions, but I'll try to be in this afternoon, depending on how busy the weather is. Try to be in for the question session this afternoon. But it may be a project idea to help us figure out how to better predict what the rainfall rates are going to be. And then some of these other ones, I know that Dr. Tissot has some projects going on these already, and I'm not sure if Tim is thinking about some side things with this or what his thinking was exactly, but forecasting water temperature response to changing weather, like for instance, when a cold front comes through, how quickly and how much is the water temperature going to fall? Because we know that water temperatures, because of the specific humidity, I can't remember the chemistry right now, water temperatures don't fall as quickly or as easily as air temperatures. So, I mean, we can forecast air temperature pretty well, but forecasting the water temperature is a little bit more difficult. And it's dependent also on how thick the water layer is. So in the bays, the water temperatures are going to change more quickly than it will over the open water, because it's more shallow in most of the areas. And one thing Tim thought was the probability of reaching certain thresholds. I know Dr. Tissot does some work for sea turtle stunning, and that's certainly helpful. And maybe adding some probability stuff into there. Predicting coastal flooding and rip currents. This is honestly one of our biggest challenges, but also one of the most difficult to try to make a project out of, I think, because of the lack of, or the minimal observations we have. Coastal flooding, we do have some observations with some gauges, but rip currents, you only know about if you see it. You can only confirm it if you see it, if somebody sees it with their eyes, or unfortunately there's fatalities. And it is a big cause of fatalities, less here in the Corpus area, more in the Northern Gulf, but we still do deal with it. And it's dependent on wave energy, wave direction, wave period, wind speed. So there's all these things that go into it. But it's almost, I don't want to say a theoretical model, but it's almost theoretical because you can't, it's very hard to verify when these things are happening. But if somebody can find a way to do that, that would be incredibly helpful to us. There's limited observational data. And then the coastal flooding also has beach erosion implications as well. I think this is the last one. Prediction of sea fog. I know Dr. Tissot is working a lot on this with a team, a national team, I believe. The timing and the extent of the sea fog, how low does the visibility go? One thing that maybe isn't part of that team is how far out into the open waters the sea fog will extend. It's difficult for us to know exactly how far out. There's a parking lot basically of ships about 10 miles offshore trying to get into the port. And it's a little harder to tell out there if the sea fog is going to be out there and how that's going to impact the folks there. The sea fog is very dependent on sea temperature and humidities. And as Dr. Tissot knows, there's very few places that we get those observations nearly coincident. Most of our marine obs do not have humidity or dew point. Those that do don't have, say, water temperature. So it's tough for us to be able to figure that one out. And that's the last challenge I have. I'm available for questions. And like I said, I'm going to try to be back for the 2 o'clock questions section. I may get pulled into operations for weather, but hopefully I can be there.
Any questions?
There's one in the chat.
Okay, so there is one question in the chat. I don't know.
Oh.
You can. I can read it. Can we get? Do you see it? Penny?
Can we get buoys and tide gauges
Yes.
in the service area? Where aren't they? It's mostly a money thing. They're funded. I'm not honestly not sure how the funding works, but it's mostly a money issue. And the one south is not very far south, and the one north is not very far north. So they certainly are helpful to us, but we don't have any specifically in our areas. Can recreational commercial boaters take advantage of the visibility network? Absolutely. They are on tidesandcurrents.com, and you can select the sites and see the visibility information there.
Thank you.
I have one more question from the audience.
So, Penny, I was gonna mention you during my presentation, but I guess since you said you might not be here, I've got a slide that has the water temperature in Galveston Bay when Harvey went over that area, and it's pretty interesting. So I could send that to you later, but nobody's ever looked at that data.
Sure.
The water temperature, so it was very interesting. So you might be interested.
Yeah, absolutely. Thanks.
Anybody else? Yes.
Hi, Penny. Thank you so much for your presentation. This is Miranda. Out of curiosity, as far as in regarding the prediction of sea fog, I wasn't sure if you guys had any cameras set out along the coast other than your visibility sensors. Can you speak more about that?
Can you repeat that? I didn't catch all of it.
Sorry about that. I'm trying to see if you guys have placed any cameras along the coast to help you guys validate the appearance of sea fog along the coastline.
We, as in the Weather Service, does not have cameras, but we do utilize some cameras from the Port of Corpus Christi. And also Dr. Tissot has a camera out at Port Aransas now. So we do have a few cameras available to us, but not as many as we would like, certainly.
Thank you so much.
There are no more questions. Thank you so much, Penny. And we're going to have a Q&A session at 2 this afternoon. So maybe there'll be more questions then. Thank you.
Yep.
Okay, so at that, it is lunch break. We have an hour scheduled for lunch, so reconvene at 1. That's the picnic one. Yeah, it's burgers and veggie burgers.
You know, you're gonna be there and you're gonna be glad. Okay, testing. Hello. Yep, okay, we're good.
Okay, everybody, I hope you had a good lunch. There's still brownies and cookies and salad. So if you would like to keep nibbling, feel free. Our next presenter is, where did it go? Evan Turner from the Texas Water Development Board. This is working.
Okay.
That's back. And
Okay. So everybody on Zoom is there. You can see us again. Okay, they're in and out. All right.
All right, so this is a presentation I definitely combined from 10 other presentations, so it's kind of a conglomerate. And they said, okay, you know, what do you do, your agency, your data sets, but also projects for y'all. And so I thought that what I would do is try to get you into liking freshwater inflow science. And I'm going to talk about a project that I did for my postdoc after I graduated here. Okay, so I thought I'd have a slide a little bit about me because I am an alumni. I was here for my bachelor's, which was a very long time ago in the 90s. Oh, is this not sharing now? Okay. And then I did an MBA, and at the time I worked in computer clusters at UT in UT Austin. And then after the 2008 economic downturn, I went back and moved back here. I taught middle school for a little bit. And then they had this PhD program now. Then before, when I was at A&M, they didn't have that. So I came back, and actually my first advisor was Sadowski. So I know there's a couple of Sadowski students here, and it was really neat. And since I had a lot of background already in computation and math, it kind of felt, even with Sadowski, well, maybe not so much you can learn with me, but why don't you go with this Paul Montagna guy over at HRI? And which, again, that building wasn't there when I was first here. That was brand new. And I jumped on his program there, and Paul said, well, you know everything about math and computers. I'm not going to teach you anything about that, but I'm going to make sure you're going to get wet and dirty and learn about ecology. And so that's what I did. So are y'all all CMSS students, or is there like some that are, how many of y'all are CMSS? So it's almost, okay. And with that, see, at the time when I came in, there were a lot of students that were returning students. That was right, that time frame. And there were a lot of us that had a heavy math background, didn't have the ecology. And so CMSS was just like the perfect degree for that, to try to get that applied science. So at the water board now, after I graduated, I got a job with the board, and we changed our mission statement. Thankfully, it used to be this huge, big thing. But essentially, the job of the water board is to make sure we have enough fresh water at the state for everyone to use. The main thing that the board does is it's like a bank. So when a municipality needs a loan, like say we need a bond for this water infrastructure project, a water reclamation plant, a dam, something like that, they go to the board and they get a loan. And then that's how they get the money for it. But also through that, there's a whole group that does planning, and then there's a science side, which is where I'm at. And it seems pretty far and removed, but the thing that we do is we maintain data collection programs, modeling, and analytics to really study freshwater inflow to the bays and estuaries. And in that sense is, how much fresh water do we really need to maintain the health of the ecosystem, but yet still have water for everyone to use? So our kind of bread and butter data set, and this is the one that I worked on the most on when I came on, is all the instruments that we have. Our real bread and butter type of parameter is salinity. So we like to think of ourselves as the #1 salinity warehouse of data. And so this is a slide from another presentation where that's the Harvey track of when it went in and back out again, and then went back in. And those are all the instruments that we had deployed at the time. And of course, when you're doing something like this, you realize that you really have to have instruments and a big monitoring program in place to catch something like Harvey, because there was just absolutely no time to go to the coast to go put anything out. It was just whatever you happen to have in the water. I remember we did have a conversation of, do we want to go and pick stuff up? And it was like, well, we didn't even have time for that. So we had it out. A little results from that, again, just to kind of show you the picture of it. This is salinity from Harvey as Harvey started dumping its rain in Galveston Bay. And those were all the sondes that we had out at that point. And this actually turned into a paper with Christian Thing, a researcher from A&M College Station. And so it's, again, this is an example of data sets that we have. If you're ever so interested in salinity data, that's one of our big things. But what was really neat about that is, see, we had instruments from the top end of Galveston Bay all the way down to the bottom. And for some of these, it took months for the bay to essentially recover to more normal salinities. The other one, which is a slide I was going to mention for the National Weather Service, when you talk about water temperature, this is actually the water temperature slides from the sondes that we had in the water. And an idea of something that someone maybe should look at, and somebody hasn't looked at yet, we have 30 years of continuous water temperature data from all the sondes that we've had distributed all across the coast. Nobody's really looked at that data set holistically for big changes in water temperature over time. And so that is a definite untapped resource for some student to look at if you're ever so interested in that. So in this talk, I really want to just try to get you excited about freshwater inflow science, which is really my PhD, what I did here. And it's interesting going, now that I work at the board, because the board has been instrumental in this. And this book was called the Freshwater Inflow Bible, that was published in '94 by a guy that worked at the board. And it's really set the stage across the whole nation for freshwater inflow science. And through time, as I've looked back at this, I've noticed that the research questions have been changing to become more complex as we know things. Really, the first thing we need to know is, does salinity affect estuary health? And of course, that was like in the 60s and 70s, and they said, yes, and we need to monitor this. Well, can we relate the changes of salinity to individual species? And that was around that time frame as well, which is true. And does freshwater inflow alter salinity? And that was why we were formed as a group in the board, and that's why the legislature said you need to be here, which we said, yes, it does. Past that, it's been, well, what will salinity be in the future? Because we've been really focused on looking backwards, hindcasting. Now we're starting to look more in the future. And the question that I got asked as a postdoc was, can we determine the health of the estuary or health of individual species if we actually add or remove water to the base manually? So an example, this is not my slide, it's just from Google, an example of relating salinity to species health. This is a species of oyster, and essentially you see the graph that the oyster, that species needs somewhere between 12 and 15 PSU to maintain the healthiest growth, and then it starts tapering off from there. So it's really interesting, when you start looking into these species that in the estuary, you need salt. It can't be fresh, right? Because the oyster's not going to grow in the river. But there's a line where, okay, it needs to be here, and then past that where it can't survive anymore, and it can't. That's why it can't be out in the open water. And so in this project that I got handed, so I graduated and immediately couldn't find a job, right? And so Paul kept me on as a postdoc, and there was a project he already had through NIFWF, and NIFWF wanted to know if there was additional fresh water that we could just add, like you just actually added it to the river. Could we determine a change in benthic populations? And so Paul had got this award already. This was before I was there, got an award, and they were going to monitor the salinity in Matagorda Bay with instruments, look at the flow coming out, and then do benthic core samples. So if you know that first floor lab at HRI where they do the benthic core samples, that's the lab that would be doing that. And just to ground you, this is Matagorda Bay. They had already planned this before I came on. They were going to be looking at these stations, either put sondes there, and the sondes actually incidentally were loaned to them from the Water Development Board at the time, and then also do their benthic grab samples. So the dilemma that I had as the project, and this is, I guess, a change of y'all when y'all graduate, and you have all these years and years and years to do your project. You're a postdoc now. The project was something that I didn't have an idea for. I didn't have any, involvement in the development, but basically we had 6 weeks left, nothing was processed, nothing was done. And we had to solve the problem in 6 weeks and basically said, we'll go figure it out, do something. Okay. So you know, so it's a completely different world than what I was used to as a student, and probably what you're used to at the moment, where you could just keep extending another year and another year. I had 6 weeks. I had to figure it out in 6 weeks. So the idea I had was, well, I'll go in 2 directions. And this is, again, like this concept of a freshwater inflow science. It's really 2 directions. I'm going to find a species in the bay to look at, even if our lab didn't measure them or study them. I'm going to have to find something that has data. And then the second side is, well, I need to look into the hydrodynamic model realm of altering inflows. I've got to have some way of, if we alter inflow to the river, I need to know how that changes salinity. Well, I can't do that in real life. So you're looking at a model to do this. And we hadn't looked at that at all, but we did have a subcontractor that was scheduled, which would be looking at a water development board model. TextBlend is the name. And he was scheduled to start working at some point. So immediately I went to, let me do oysters, because the number one reason is they don't move. And if any of y'all, I think there are a few people that do finfish stuff, right? Are there some students that do finfish things? I swear, I think some of y'all were. It's really hard to do freshwater inflow studies with finfish because they move. So but the oyster also has this great wealth of research already and data sets, and we already know that they're influenced by salinity levels. And then, you know, it's a economic crop. There's going to be stakeholders involved with this. This is going to be a good thing. The problem is it's more complicated. So when I actually looked into the life cycle of the oysters of what I have to model, there's going to have to be multiple equations for this, because there's going to be different growth for the spat, which is the juvenile oyster, versus the adult oysters. They also have these mortality conditions that occur. And that all of these things mean now I have to essentially make a model for these. And where if I was looking at Paul's benthic data, probably would just be one equation. So it makes it more complicated. And so what I did is I created this thing called the Oyster Health Indice, and this is something that Jenny Pollock's lab does a lot. I don't think she's even seen this lab, this slide, but and I didn't really use hers either. But I created a known, at least from one that I know that I can make, I could get these equations calibrated to data that would have through POCCA. Okay, so now I've got multiple equations for this. And one equation I know I didn't need is that oysters there is an equation for the substrate, because oysters have to, they can't just attach on the mud. There needs to be something there. But we already had reef locations, so I get to skip that. So at least that's one line I didn't need to do. Then this next one was, okay, TextBlend. And this is the model that the water board has. And it's a model that can run for 30 years from 87 basically to present. At the time it was 2015. And so by looking at data from actual observations in the bay at exactly the points we were looking at, it actually calibrated reasonably well for salinity. The R-squared was 0.75 for salinity, which is not too bad for that, and apparently it's actually quite hard to model salinity in one of these models. So after looking at this, I said, okay, this is possible. So with this model, then if I add or remove flows to that model, then I can now alter the salinity over across a single point, a single GPS coordinate. So my process in doing this was, I'm going to calibrate that oyster HSI to the POCCA data set. Then I'm going to map the oyster reefs to a TextBlend model node, then run TextBlend with altered run scenarios, calculate the change of salinity based on that inflow, and then calculate then what the HSI would be based on the salinity. And then you end up with a number. So here I'm trying to essentially take this qualitative sense of oyster growth and convert it into a quantitative number. And what ended up is through this, I wrote a paper about a statistical process I used to actually grab the data out of the parks data set. So this turned into its own paper that now Paul uses this method. And it's essentially, you're trying to find the maximum possible growth stage of any ecological divider to some physical parameter like salinity. And so this side on the left, that's the parks data for all of oysters. And then on the right, then I calibrate that, use that term and turn that into the equation on the other side. So what I found out is that this did match the real life of what the oysters look like in our study area. And then with the text blend side, then I can now say, well, here's the salinity over on top of those reef locations given inflow to the bay. And at the very end, then now I can have on the graph one side being oyster growth and the other side being inflow. So that was the actual end result. And what we found with this was at the end of this project was that the inflow required to lower salinities to any kind of preferred level for adult oysters, just completely physically impossible. There wasn't enough water you could buy. It would be an astounding amount of money. It's just not possible. However, since those oysters had such a complex life pattern and that the juveniles actually preferred higher salinities, if you added a little bit of water during those spawning months, you did get a significant increase in overall oyster health overall, because you were able to take advantage of that. So that was the end result. And this actually was one of the founding principles behind this group called the Texas Water Trade. It's a group that now they are looking at buying water rights or gifted water rights, and then in putting that water into the system to have this kind of a game. So, you know, at its heart, freshwater inflow science is interdisciplinary. And that's what I wanted to really give out to y'all by this just example of what I did, is that you have to combine biology, ecology, the physical hydrology, which is, you know, the salinity, those physical parameters, and also with computer modeling and statistics. And so to be really successful as a CMSS student, I found that those were pretty well essential. Anyway, so that's really all I have. With the slideshow, I guess it's a little under time, so I've got plenty of time for questions. Yeah. 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 So the salinity we have, like the water temperature is a good one. So water temperature, because it comes with all the instruments already. And so here we're trying to really measure salinity. That's like the number one thing we do. You do have to have water temperature to calculate that. So that's why it's on those instruments. But then it's sort of like a tertiary parameter that we don't really care about, like in terms of writing a report or anything else. So all that just kind of sits there and hasn't really been used. There's also, you know, essentially 40 years worth of different reports that get funded, and then we get the data for that and it gets put on the shelf, right? And as the ledge changes what they want about every 10 years or so, things will come back in favor and out of favor. So another good example of one is there was a tipping bucket. It was a bucket experiment. So back in the 60s and 50s, I think even the 50s, to measure turbidity in the rivers, what they did is they paid local farmers to go out with a bucket and sample the water in their local waterway, and then write down what they saw essentially and put that down. And all that data, then it stopped at one point, once people went to roll sensors like USGS went to actual turbidity sensors, that project stopped. Well, all that data, which is a good 10, 15, almost 20, maybe even 20 years worth of data, is really just sitting in a box. It's not digitized. Nobody's looked at it. So that's another kind of great example of that. So, and through the years, as our agency has changed and other agencies come and go, we've had people like dump things off on us like that. So that was a great example. That wasn't actually from our agency. Another agency just actually handed us the box of data, and just, it's in our back storeroom. So we've got essentially a whole room of that kind of stuff. Yeah. Any other questions? Those wouldn't be. I think the water data that we do have is all online. Like the water temperature data it can be kind of a mess, because you're looking at instruments that were put out for a small period of time, or there's breaks in the data set, but that's all online. We do have like the text one data. Well, that's all there. In fact, it's all done. So, if you're wanting to know the change in salinity for any of the coastal region since 1987 to now, that data set's downloadable. So for a project that was, that's an easy one. Yeah. Yep. That was all Parks data set. So I'd have to look and see what they had. I think it was spat abundance actual count, I believe. Yeah. The hardest part really is working around these other agencies' data sets, because they had their sample regime, and that's what it is. What makes their set hard, it's this pseudo random sample design. And so they'll pick a point and they'll go do it. And so if you're looking at, like, say, water quality, so that one graph I had that had text one water quality over that same node, I had to match up at what point in history did they go back somewhere very close to that point, and it could be years before they came back. But over the course of 30 years, I was at least able to find points they did. And that's in real contrast to, say, the sample methods like Jace has, where you have a fixed station and you have all your samples at the fixed station over time. It just makes it a challenge to interact with those two. Yeah.
Data, or thinking the first one of data with some freshwater inflow data or data. It's oftentimes what we're saying are these, at least that, at least big with us. So even though it's kind of a weird data set, it's like you either get a huge recruitment event that year or you don't. And so linking that to what's happening in terms of the data flows and global climate cycles and things like that, it's still pretty clear what's happening with recruitment. And maybe with the folks working instead, but maybe with the larval fish recruitment as well.
Yeah.
Pretty clear when it's happening.
Right. And that's why you end up with a graph like that on the left. And then the real challenge becomes, how do I get something meaningful out of this to get it to the other side? And so that was what took me the honestly, the majority of the project was try to at least like, you know, here I'm pulling that line out. If that line really is the line, I don't know, but at least I have a consistent method to pull that out because, and that was the trick, right? Because it on the left is exactly what you get with ecological data. It's just a mess, and a lot of it's on the bottom because you have no data. It's a line off the bottom. And so you got to have some real statistical tricks to get it into something that you can use for your computer model. Yeah.
Environment, they actually, so you should be able to do something similar with actually changing fish populations or local fish population that they set by so absence of species can be as well as
right. There's whole people that make their careers out of doing this, but for finfish, it's just a lot harder. It's harder, but it's possible to do. And so I definitely like that's something we're very interested in at the board to, and then also Parks and Wildlife to go in that direction, to look into that. If anybody wants that project for that, I would say it is something definitely to look into. Yeah. Yes. Yeah. Oh, there's a question in the chat.
From Catherine Maston, your work is very relevant to concerns about plans for the city and Port of Corpus Christi to construct desalination plants inside Corpus Christi Bay. What is your opinion of the wisdom of them doing that? Specifically, what unprocessed data sets and studies on salinity do you or Texas Water Development Board have that show the relationship between freshwater inflow and salinity levels?
Okay, so I'm gonna highlight that unless specifically noted, this presentation does not necessarily reflect official board positions or decisions. So I definitely don't want to get myself into trouble. So because the board is the entity that they get the loans to do these projects, right? And there's also like we're not involved with the planning of this at all, like because there's a different group that does planning. And I remember asking, it's like, well, this is sort of relevant to our area, and we are not looking at those projects. And the reason is that we just not feasible, because if we look at that, we'd have to look at everyone, and it's not feasible for us. We wouldn't have enough people to do it. In terms of this is, you know, you're taking fresh water out of a saltwater body. The thing is you end up with brine that has to go somewhere. And it has, you know, so you have hypersaline water that has to get pumped back somewhere. And to be honest, I'm really not, I don't know a lot of the specifics about the Corpus project or even the port project, but it all depends on where you're putting that to make sure that the water that you're releasing isn't sort of like robbing Peter to pay Paul situation, right? Where you're, you know, so you're desalinating the water, but then you've got brine that goes back in, and then you're releasing the fresh water on top of it, and then you're back to just neutral at that point, right? So, and I think with these projects is there is a lot of work on that, of where they're putting that, and then modeling of how that works. And the hypersaline water just physically is more dense and will go to the bottom. And I think that's part of what that, so it's not my project, I don't know, but I think that's part of that, is because if it goes to the bottom, then it can leave the estuary. And I think that's what they were looking at the time. Yeah. Yeah, this is actually the worst question I ever got in a presentation that I'm being recorded on. Actually, very worst. So, you know, but this the thing, as a scientist, you're a scientist, you have to have objective answers, and that's our job, to give, you know, objective data, objective answers that we can give up to the policymakers for them I don't make the determinations, they do. And that's my job, right? And then through that project, again, they have their own studies that go about it and look at those things, and I know that they are doing that.
Catherine has a follow-up.
Okay.
My burning question is there a relationship between freshwater inflows into and desal plants placed inside the bay?
Well, I don't know, because have there been any that are actually completed with data? So I think that would be something you would look at with, if you had salinity monitoring, good monitoring from the get-go, and then you put the project in, and then you have to look at it statistically afterward. But I would think you would need, you could probably look at it through a modeling study, but it seems like the real in question would be after a project is done. So you look somewhere else in the world that has already put it in, and then you can look at it. Yeah. It would be right. It would be right. Which I know that they've done. Like I thought that was part of what they did, was they had to run scenarios of the changes of that, of what that would occur. Yeah.
Thank you.
All right.
Our next presenter is Sarah Garza from the Port of Corpus Christi Authority. And she had an unavoidable meeting conflict today, but she pre-recorded her presentation. And if the meeting finishes on time and the weather permits, she was going to try and come for questions later today. And then she and one of her project managers will be here tomorrow.
My name is Sarah Garza. I am the Director of Environmental Planning and Compliance for the Port of Corpus Christi. I'm sorry I'm not able to be there with you giving this presentation in person, but we do have our Port Commission meeting, and I wasn't able to do both. So what I want to do today with this presentation is give you a perspective of the Port of Corpus Christi, talk a little bit about our environmental perspective, what my team does, dive into some of the data that we are collecting, and then talk about some projects that we think that if you all are interested, you may be able to help us on. So with that, I'm going to go ahead and jump into the presentation, starting with who we are. We set out some time ago and identified ourselves a mission, which is to be the energy port of the Americas. We have accomplished that. You'll see that in the course of the next few slides. But essentially what the Port of Corpus Christi is a political subdivision under the state of Texas, which is responsible for commercial development. We are responsible for ensuring cargoes in and out of the Port of Corpus Christi. The port owns just under 30,000 acres. Some of that is submerged, some of that is upland property. And what we do with that is we develop the property or lease the property and allow others to develop it. We are governed by 7 port commissioners. 3 are appointed by the city of Corpus Christi. 3 are appointed by Nueces County, and 1 is appointed by San Patricio County. So you can see here some statistics about the Port of Corpus Christi. The biggest one being that we're #1 in crude oil export across the nation. We are #1 U.S. port by annual revenue tonnage. And then #2 in terms of LNG exports. All very significant statistics. You can see over here on the right-hand side, the economic impact of that. Nationally, within the state and also here locally, $6 billion locally on a daily basis. We provide 98,000 jobs through the Port of Corpus Christi, whether that's direct or indirect jobs. So significant impact within the state of Texas, within the whole US, and of course here locally. Our crude oil exports have continued to increase. In 2015, prior to 2015, there was a federal ban on crude oil exports. Since that ban was lifted by Congress, we have continued to increase in our crude oil exports with record tonnages on a monthly basis and on a quarterly basis. You can see here that in the fourth quarter of 2022, we moved just under 50 million tons. And we had another record year, another record quarter just this last quarter. And so crude oil continues to be a very important commodity within the world marketplace. So you might be wondering, how does the Port of Corpus Christi set itself up to be so significant in the crude oil export business? Well, there's a few things that we have going in our favor. We have a great energy supply here. We have thousands of acres that are consolidated in order to provide for big energy campuses. We also have a deep draft port where we're 54-foot port, which is the most improved ship channel on the Gulf of Mexico. In addition, the world fleet currently utilizes Suez Max vessels and VLCCs. So Suez Max is just the size of the vessel. It basically means that it can handle 1 million barrels of cargo. And so the channel has to be a certain depth in order for those vessels to pass through. We have a highly skilled workforce here locally. We have excellent air quality, and that's due in large part to the community, industry, government, all coming together to ensure that we stay in attainment of our air quality standards. And then finally, we are providing a carbon management solution for those entities who are wanting to invest in decarbonization strategies. We have the ability to create a centralized, scalable onshore and offshore carbon storage solution. This helps us to be able to set ourselves up for a clean hydrogen hub. This, hydrogen is a fuel that several of our industries are already using here in the Port of Corpus Christi as part of their refining process. Some other industries are already thinking about transitioning to hydrogen as a fuel because it is a low carbon alternative to natural gas. And also we have existing pipelines that provide the infrastructure for a hydrogen hub and have extensive relationships, long-standing relationships with customers who are vetted and well capitalized and able to enter into this solution with us. One of the things that we also bring to the table is the ability to create this centralized carbon capture system. And with that, the port would be able to deploy its capital in some key infrastructure elements, and then with that, be able to pursue federal dollars. These are solutions that basically set out an opportunity for large companies who are interested in pursuing their decarbonization strategies, a solution for them without having to take on credits. It's in close proximity to them and really, as mentioned before, scalable. So you can see here that hydrogen would follow these trade flows that are here on this map. These trade flows are actually existing trade flows for other commodities that we already move. So we're not creating new directional cargo movements. These are just following existing trade corridors, which also helps us to be strategic in providing hydrogen. So I'm giving you a perspective of what all is happening on the energy front within the Port of Corpus Christi. That just barely touches the surface. We could go for hours talking about the details of the Port of Corpus Christi. But one thing I want you to take away from that is an understanding of, while all that stuff is going on, we have committed to being an environmental leader. How can we be an environmental leader with all that going on? We have a really robust environmental policy. It contains 6 precepts. You can see them listed here. And underneath each precept, we have included a target for what we're going to accomplish under each one of these precepts. This allows us to benchmark our environmental performance and really creates this opportunity for us to do really great things, both on the commercial maritime front, but also on the environmental front. And I'll get into some of these precepts as well as the targets and some of the data we're collecting here in a minute. But most important, what I wanted to know here is that we have these 2 precepts, climate action and climate adaptation, that relate to climate change. So this is a recently updated environmental policy. You can see that what we're trying to do is to stay current, make sure that our policy is current with what is happening in the world today so that it's relevant. Some other things to know about our environmental policy: it pertains only to port operations. This does not extend to our customers. It doesn't extend to our tenants. These are performance targets that are data driven. They are tied back to annual tonnage so that they're realistic. If we have an increase in tonnage, then you would not expect certain things to go down regardless of what's happening with the tonnage. So when you compare it and correlate it to the annual tonnage, it makes it what's called actualized. It is extrapolated from data that we've collected over many years. So we're very confident in what is happening in the data and what changes we think we can make. And we also believe that it's achievable with the department work plan that we developed year after year. This, as I mentioned previously, this policy is an opportunity for us to really enhance transparency around environmental performance in the Port of Corpus Christi. This slide here, I'm not going to read everything that's on it to you, but what I do want you to take away from this is the understanding that each one of these precepts was thoughtful and intentional and built around existing frameworks. So we didn't want to start over. We wanted to take advantage of those frameworks that are already existing through a vetted, data-driven process, and in most cases already include a functioning scientific advisory working group. This will set a baseline for us and the recognized standards that anybody can understand where we're coming from. We're not going out trying to recreate anything. This environmental policy is relevant to both imports and exports. It's relevant locally and nationally. And again, it's the same reference points that all of our stakeholders understand. All right, so as we are talking about our environmental policy, I want to just for a second talk about my team. I have a team of 11. We have 3 functional areas within my team. One that covers permitting, one that covers compliance, and then one that covers sustainability and resilience. I talked about our department work plan already. Some of the other tools that we use include an ISO 14001 management system framework. That's a framework that basically allows you to continually look at your operations through a plan, do, check, act cycle. And each round around that cycle allows you to continually improve. Another thing that I'll dive a little deeper into in the next slide is green marine certification. a maritime certification that is specific to the port industry. And then, of course, we have a number of initiatives under our department work plan, including the use of GIS. We have a stormwater master plan. We are developing a sustainability action plan. And then we also have a number of strategic partnerships that really allow us to increase the benefit and impact of what we're doing. So I mentioned the Green Marine program and the certifications in Green Marine program. We've recently, as in this year, been certified in level 5 of all the performance indicators. So basically under each performance indicator, there are 5 levels of achievement. The board has accomplished level 5 in each of the performance indicators that are applicable to us. And what you can see here is a number of different programs, initiatives, projects that we have undertaken, excuse me, that we have undertaken that help us to accomplish that level 5. You can take a quick look at this. These are things that really help us to collect data, move the needle when it comes to accomplishing each of those targets. All right, now in the next couple of slides, I want to get into some of the data that the Port of Corpus Christi has been gathering. I told you earlier that all of the targets that we have are based on data that we've already been accumulating. These slides here provide some examples of that data. So for instance, with regard to air quality, we track a number of different metrics around our fleet, including both vehicles and equipment. And then we also track fugitive dust out of the bulk terminal. We have an air monitoring network that provides us real-time data about dust and provides operational alerts that give us the ability to manage our operations so that there are no dust impacts off of the property. With regards to water quality, most of what we monitor is connected to existing multi-sector general permits that are managed through the Texas Commission on Environmental Quality. We have been collecting data out at the covered outfalls for over 20 years. So there's quite a bit of data there that both in terms of how much rain over what time period and what are the pollutants in stormwater runoff. With regards to soils and sediments, one of the things that we track includes spills that occur within the port area. In the Port of Corpus Christi, we have, for the full time that I've been in the Port of Corpus Christi, which is 21 years, we have been responding to every spill that happens in the port area to ensure that all spills on port property are cleaned up to background. And in the case of spills that can't be cleaned up within a short time frame, we track that cleanup over time to ensure that eventually it gets back to where it's supposed to be. The idea is that if you have a spill on port property, but you can't clean it up to background, then you have to deed record the property to show there's contamination there. And when you deed record property, it encumbers the property, so future developments have a bunch of hurdles that they have to jump over. So for us, it's better to maintain that property without those encumbrances. So we have been tracking spill data. We do a cross section of where the spills coming from so that they can target our outreach to users in the port and work with our tenants for improving best practices. Next one I want to talk about is the climate action. These data trends are very similar to what you've already seen. Again, this is a look at our fleet and the carbon dioxide emissions coming from our fleet. Also, the Port of Corpus Christi has been utilizing renewable energy credits for all of our operations. since 2017. And you can see here, even in spite of the purchase of green energy credits, we're still working on programs that will reduce our energy consumption. This slide here gives you a perspective of habitat creation. So one of our presets is habitat creation. What we want to do is be able to create habitat within the Corpus Christi, Nueces Bay water bay system. And so we went through a process with a partner, Ducks Unlimited, to identify opportunities for creation of habitat. Creation of habitat typically requires a sediment source, and there's no better sediment source in Corpus Christi than dredge material. So our channel, we maintain our channel, water quality is very good. The Texas State Aquarium sits on the Corpus Christi ship channel. It is actually able to draw water out of the ship channel because the Corpus Christi area, ship channel, bay, Nueces Bay are all very clean. So with that, we're able to reuse that sediment and create habitat. These dots on this map indicate some of the places that we were told through the stakeholder process, hey, these would be good places to place material and create habitat. So again, I talked about our department work plan by focused area within the bi-functional area within my department. You can see we have a number of key initiatives. Resilience and sustainability really kind of speaks for itself. The biggest accomplishment that we have is green marine advancement, achieving level 5 in all the applicable program areas. But one of the things about green marine is that even though we're at level 5, the way the program works is they continue to add technology, practices, things that will just continue to increase that voluntary participation and take you beyond regulation. We want to stay well ahead of regulation, and by continuing to investigate new technology and practices that help prevent pollution, we're able to do that. In the permitting, that's exactly what it is. Providing permits in order to do new infrastructure, and then compliance is about once we have established what our baseline is, making sure not just that we're following regulations, but where we make commitments to go beyond regulations, we're doing what we said we would. So here, this slide provides to you a list of basically some data gaps or suggested projects that we think would be good opportunities. I've listed them by precept. I'll just run through these real quick. Under air quality, we want to look at the reductions that are associated with the use of different types of fuel within our equipment. We also want to look at air emission reduction strategies for rail, trucks, and vessels. We have an organization that we are a membership. We have a membership with. I'm actually the president of the board. It's called the Coastal Bend Air Quality Partnership. And they are working on a Coastal Bend Clean Air Action Plan. And under that action plan, it's about identifying initiatives in each of the sectors that will help us be able to maintain air quality in the Coastal Bend area. With regard to resilience and climate adaptation, again, that green marine performance indicators, we want to identify additional strategies that will continue to raise the bar. We want to establish sustainability baseline metrics, and then really identify places where we can do reductions when it comes to water consumption, and also consider alternate sources of water for dust control. A lot of water that's consumed at the bulk terminal is for dust control, and this will allow for us to use other sources and not just take from the municipal supply. Finally, in soils and sediment, we wanted to develop a sediment characterization database. So with all the sediment that is dredged up, there is sampling that's associated with each of it. And so what we want to do is create this database of all that sediment sampling. so that any cross-section of the dredgement of the road can be evaluated where data exists. With water quality, we want to develop a database of green infrastructure and stormwater quality best management practices, and then the associated pollution reduction values. We want to develop a database of the existing water quality sampling that has been done for the inner and outer harbor, and then develop a database of ballast water technologies and the treatment rates associated with each of those technologies. With climate action, we want to evaluate the emissions reductions that are realized through green shipping corridors. Again, green shipping corridors are those dedicated corridors that offer the most efficient trade routes in order to reduce emissions. And so when they've done that, we want to evaluate, there's a number of green corridors, we want to evaluate the emission reductions associated with those so that we can factor those into our decision making. And then finally, with habitat creation, we want to create a database of ecosystem value, the metrics that are both already captured through work that scientists have done here, scientists and biologists, and also even identify that data that's missing for our area. So with that, I thank you for the opportunity to speak to you today, and I look forward to catching up with each of you individually tomorrow. Thank you again.
Okay.
So now we'd like to open it up for Q&A for any of our stakeholders that are present, online or in person. We have two more. All right, we wait, we listen, and hope we took notes and we have a lot of questions. So, would like to start. Actually, we do have everybody else online available to answer questions too. Online, we have Ingleside on the Bay and National Weather Service. Okay, and from the 4th to the tomorrow. They will definitely be available. Oh, and Meadows. Yes. Okay. So who's going to start first? Okay. Yeah.
Thank you for the presentation. And today I heard about a few questions about the ship dredges, about the issue it takes to the tide and how it affects the habitat. So I tried to look for some data set online to see the traffic of the ships, so we can know what weight and what volume of the ship is crossing the port. And I found automatic identification system that data set that is for the whole United States. And I wonder if anyone has some available data set that can suggest it to us that we can use for ship traffic.
Yeah, I think that's going to be a question for Sarah or the project manager tomorrow. Well, RJ.
Usually you can contact the port and they'll have a ship log of all the ships that have been in and out of the port. And then you could probably get the AIS number for those vessels and run that number individually to find out exactly where they were moving.
Okay, thank you.
It's more of a working question. we're trying to apply some type of machine learning application or artificial intelligence application to answer some of the recent questions that you guys have posed today. But a big emphasis, and something that we rely on within the machine learning world is the access to data. And a lot of you guys have spoken about some of the data sets that you would be presenting to us and making this accessible to us to work on throughout the summertime. But my question here is today, is there anything that would be something that we could look at today or in the next few hours and next few days so that we can come up with some type of data fact sheet, data dictionary, so that we can create some type of metadata set, so that we're not impeding on your time throughout the summer on some of what the variables may mean for our outputs, for our input within the machine learning model. And it's a good way to fact check and keep up a log of what we're utilizing in our machine learning tools. Or if I can make that question shorter, because I know I rambled, is there data that you have brought today so that we can, as a group, go through it to make sure that we understand what kind of inputs that we may use within our machine learning models?
Okay, I can answer that.
Yeah, I'm a bit long-winded, I apologize.
I mean, I can easily bring it up, either one of those, and we can go through and talk about, what things mean and don't mean. That wouldn't be a problem.
Yeah, I think that would be helpful because my next question would be, I know that there may be some collaborations that we could have within the stakeholder groups that are here today. There are about 7 groups. There's about 14 of us. So if there's a way to combine a lot of those data sets and some of those research questions, that would be probably the most fitting for resource availability within our group, in our skill sets.
Okay.
Thank you.
And probably, so we would probably talk after this too, because, I mean, I could literally show you the SQL schema of the whole database that we have and how the database works and then how to get all that out from an API. It's just, every database is a little bit different, but I do know that the databases that we have and like with Jace would have and CBI, they're all pretty the same kind of stuff. And so as long as you know what that API is for each one of those, you can combine what you want together. So yeah. I think the same thing for y'all's too, right?
I'll say from the National Weather Service perspective, most of the data that I was talking about earlier, most of that is going to be available online. The radar data, archives, satellite, model data, observations, I think is going to be the big one. It's all available online. I don't have any examples on me, but it's generally going to all be available. Some of it even up to every 6 minutes, I think.
Perfect. Thank you so much.
So some of we collaborate with some of the stakeholders, and so for water levels in Calhoun County, for example, that's going to be from the water level databases, and we will provide the data. For cold stunning, then I think Miranda would be your source. For the fog problem that Penny was talking about, that'd be a little tough. It's I think if some of the students group want to work, like for example, a fog prediction problem, and there's going to be problems at the water development board with Jace, we could look at collaboration, like tackle a smaller portion of the problem, or find something that's realistic to tackle during the summer and maybe in the fall, and we can tell us what you're interested in, and we're gonna help make it happen.
Jennifer, I see that your hand is raised on Zoom.
Yeah, I just wanted to mention that our air quality data for the pollutant monitors, we could provide that data for the last couple of years in raw format, if that's what that's what the students would like to look at. We could email them or send a link for Google Drive for all of that raw data. Thanks.
I also want to say that our stakeholders, if you have any questions for our students, you can ask also. It goes both ways.
This is a question to Penny about the National Weather Service. You mentioned that you need help to improve the prediction of the precipitation and the fog, but we would like to help. And we know we can download all the data from model data and the observation data from a NOAA website, but one thing we cannot find is the historical prediction from your agents. For example, Corpus Christi, what was your 24-hour forecast? What was the 48 forecast or 48-hour forecast? Those data we have nowhere to pull up from NOAA. So many times when we look at the validation of your prediction, I guess it's your kind of internal data for you guys to use to evaluate your prediction, your forecast quality, but those data are not open to the public. And for the student to be able to help, for example, to improve the prediction, we need to know what is the current status. How good are we at the moment? If we invent something, if it's not really better than what you already have, then we are wasting our time. I hope we can provide those data to our student.
That's a good question. I'm off the top of my head, I can't think of where there would be an archive of it's the QPF forecast, I think is what you're looking for. And I will reach out to Tim this afternoon and see if he can have an answer for you for that tomorrow. There is what I had mentioned earlier in the presentation was a rainfall rate forecast, which is not going to be a one-to-one match with the QPF. Our QPF forecast is more of an aerial average forecast, but we know that in heavier thunderstorms we're going to get higher amounts. So our QPF forecast doesn't exactly account for that because we can't predict exactly where a thunderstorm is going to be to try to say exactly where those higher amounts are going to be. So there is a difference if you're looking at a project on rainfall rates versus our QPF. But I'll have Tim talk a little bit more about that tomorrow when he's on. He'd have more answers, I think.
Thank you. Yes.
Do you store the NDFD predictions?
The NDFD?
Yeah.
I'm not sure if they are archived somewhere or not. They probably are, but I'm not entirely sure.
Any questions? I have a question for, I guess it's Patrick and there was a couple other people, Jennifer maybe, for the Ingleside on the Bay. It seemed like y'all had a lot of information and a lot of things that you're interested in and a lot of desire to move forward with analyzing the types of data that you have. I was wondering how much of this is actively being researched, because I mean, there's obviously, we don't want to step on people's toes if they're already doing work, and I also don't want to waste people's time by doing work that's already potentially being done. I know that there was mention of non-campus having the aerosol data being analyzed, but I'm not sure if y'all know if they're actually doing things with that data, or if they're just analyzing it and giving the data back to you. So just kind of wanting to see if y'all had active projects right now going on with this topic management.
Yeah, thanks for the question. So we do have we currently have a grant that is paying for support from Texas A&M with Dr. Felix and his grad assistant Yishi Hui, and regarding methane studies with Dr. Coffin and How You. These they help gather, they pull the data from the monitors and then provide monthly graphs of the data that reflect wind direction and weather patterns with it. At the end of the period of the grant, specific to their topics, with Dr. Felix and Yishi looking at the pollutant source monitoring, and Dr. Coffin and How you're looking at greenhouse gas, they will provide a report about what they've noticed in the results over the last year, because this grant has been going on for a year. So we can provide you with the scope of what that is. We also have optimal gas imagery monitoring around the coastal bend as well, and would love to see how this data could all be brought together with that gas imagery, with mapping. I think there's a lot of other things that can be done with the data besides the level that we have looking at right now. But we'd be happy to talk a little bit more about that tomorrow, and we can bring some of the descriptions of their work that they're providing.
Thank you, Jennifer.
You're welcome.
Questions? I know everybody took notes. Yes.
I have a question for the Calhoun County. I know you were thinking about road flooding and working with the judge and everything. So are you interested in how mitigation can affect the flooding patterns, or strictly just looking for analysis of trends in flooding for like a dashboard for end users to see? Or are we trying to see like how we should go about changing and including that in our model for future predictions?
At this point in time, we're looking at public safety issues. You know, I mean, the main thing is, let's not send an ambulance in the water at 3 a.m. and lose it and not be able to get to somebody. I know the solution is probably to build the roadbed up long-term. That's not always feasible. So if we can come up with something to give the decision makers a little bit of lead time on when to close the road down, and we prevent a death, we're ahead of the game. So that's kind of what we're looking at right now. I could see it going further, but right now it's a public safety game.
I was actually going to ask Jace this, but since he's right here, and I think it'd be better for everyone else. So I know that in the past, y'all have had chlorophyll sensors on those platforms and with the exos, and we've been using those as well on different deployments, and we're probably going to put those on our buoys. I'm wondering if anyone has done any kind of analysis of those, that data that you have for looking at harmful algal blooms or otherwise trying to model the distribution of that, because that there's some of those things have come up recently in our area, and people have asked us that, can those do that or what, or can that be part of that? So I was wondering if that's something that y'all looked at.
No, we haven't looked at that, so no, that's a possibility.
All right, so this question is for Edwin. So I have been here for the past hour around the campus. So you showed the temperature data from the water driven board. Like, is the data public access Yes, it is. So I don't know, did you show that on your slide? So,
No, it's on our website.
oh, it is.
So, yeah, so it's Water Data for Texas is the website, and then at Postal, and that's the database that I run, and it's in there. The thing is though, is when you find that it's based on station, which is sort of like what Jace's is, it's kind of hard to then go, oh, I want all of the area of all time. You know, just the way the nature of these kind of databases work. And that's why I was saying, and looking into the API, if you want to get like a whole area of data. And I wouldn't recommend, I mean, you could ask the database to give you everything. I wouldn't recommend it because it's probably going to crash it. So if you want the entire database, it probably would just be easier to ask me, and I could just hand you one giant file and it's done. But otherwise it is all online.
So what is the measurement frequency? It's based on the song?
Yeah, the song is generally once an hour. And that's been pretty standard since the 80s. We've just found for water parameters, they don't change that frequently. I've certainly experimented with stuff that's like 5 minutes or 15 minutes, but generally things don't change for about once an hour. And then also for the wipers and such, when it wipes the membranes off in things. I think yours are 15, right? Yeah, the wipers. Yeah, so we've generally just kept ours at an hour, and that's pretty standard for the entire 40-year data set.
So regarding the sea surface temperature problem, is the issue of data cleaning, gap filling methods, interpolation methods, or some type of profile, Texas profile of temperatures along the coastline, or is the tangible benefit for you regarding the sea surface temperature some type of predictive model for temperatures, or is it data cleaning?
Probably for both. I mean, you know, in terms of it, obviously needs to be clean. And I can show you a graph and show you why it's a hard process, because even if a station has been there for 20 or 30 years, there's a lot of holes in it. These are not, you know, real high dollar platform stations. Generally, it's a sawn hanging from a rope off of some structure, and the structure gets hit or breaks up or what. And the temperature, though, it doesn't tell. Like that one can get buried, it doesn't matter. The temperature is great. Usually the fouling is the other parameters, and they foul kind of differently. And that's what makes the QA harder. And plus, like any kind of AI or system, you know, harder to do that. But if you were able to, you know, for one, you're going to have to interpolate the things that are missing to get like okay, here's what has occurred over time. But it would be good for us to know. And I think people would want on the public, if they look at the graph, they would love to see, okay, here's the average, here's an interpolation of it, and something that would generally work. And, you know, we could do those things too. But it seems like that would be a good project if you were really interested. In another meeting, I think we were at, it was the MTAG meeting. Anybody else was at this MTAG meeting the other week? I think maybe some of the other. So what came up was there was in the sea level rise meeting with Jim Jabot's lab, and they were looking at sea level rise in the area. And one of the research questions they had was, why is our area having more sea level rise than the national average? And there were really two ideas. One of it was subsidence or localized water temperature. And we would be the ones, if you really wanted to answer if it was localized water temperature, you would need water temperature data, but we have a lot of that. So those are, you know, that would be a research question you want to see. I mean, my hypothesis is it hasn't changed compared to the air temp, but I don't like, I haven't really dug deep into it. So yeah.
Right.
Okay, I'll read it. Catherine, unless you want to read it, you can cut me off, but in the room, the question is, when considering proposed projects for specific stakeholders, like the port's idea of a database of ecosystem value metrics for habitat creation from channel deepening, I would like to encourage including metrics for habitat destroyed by channel deepening as well. As IOBCWA shared, seagrasses have been destroyed. TWDB has a seagrass viewer, but the loss has not been quantified, and there's been no attempt that I'm aware of at predicting future seagrass loss in connection to species impacts. There should also be some qualitative aspects of sediments that have been captured, for example, toxins, and might be amenable to big data analysis. All these measures we're talking about, sea level rise, weather patterns, salinity, soil sediments, oil and gas, etc., impact the quality of life at IOB. How might big data predict what will happen on Ingleside on the Bay if current trends in climate change and industrialization continue? I do know, I think it was mentioned earlier, but Kurt Cameron is doing some work with seagrass in the area. Maybe that was something that Jennifer or Patrick mentioned. So I'm not exactly sure what that study is, but I've heard about it a few times. So that might be worth looking into. I don't know. This is sort of just a general comment, or if it's for a specific stakeholder group.
So just to get this idea a little further, and I think we just, I heard this through a couple of presentations, is really understanding how industry and industrial settlement and industrial activities actually change jointly with these environmental parameters like salinity or influence, or jointly with this parameters like salinity and temperature actually modified habitats in the system. And I think this is the overall global big data problem, which came out of the stakeholder meeting and the stakeholder discussions, which is something the group could possibly address. So working on those smaller aspects and then coming together as a full group to make an overall prediction. I think that will be something really interesting to actually understand how industrialization with these certain companies which are majorly based on fossil fuels or fossil substances, microplastics are coming from or are associated with oil production as well, would then actually go together and change the ecosystem, and what are measures which can actually be done to remediate it or to mitigate that, and placing values in them. Just as a general idea.
That is a big question.
Yeah, a really big one and challenging. So, but I agree that it could incorporate several projects that may be bringing everybody together at the end. What data are available besides the natural influences, environmental parameters? I don't know. There is enough there to. I think there is a gap, and it might be a gap in actual data available. The seagrasses, for instance, right? I think it was mentioned there's some studies, but there's a lot that's done.
For years.
So I was just adding, I didn't think about it when I was mentioning earlier, but Ken Dutton, of course, has his state seagrass monitoring program that's existed for many years. It's fixed sampling stations, if I'm not mistaken. It, I think, focuses on the places that have historically had seagrass. I'm not sure if it's extended into new areas of seagrass. But that's one other, potential data source of seagrass, and I just don't know how well spatially distributed it is. I don't know, maybe Jace, maybe you know a little bit more about that.
Yeah, they have all that data available at texasseagrasses.org. Is you can go and look at all the maps, and you might be able to download the data there. I don't know, but they had, it's a tier. There's 3 different tiers. One of the tiers is there's fixed stations. They do that maybe every 4 or 5 years or something, but what they've been doing every year, they're random sampling stations within polygons, and they sample 95% of all the seagrasses in Texas. But yeah, so they have species changes over time, and some interesting stuff, especially when looking at there was one of those years, there was a flood, 2011 or something like that, down in the lower Laguna Madre. You could really see a shift in the species of seagrass that changed. I mean, huge areas. So definitely, salinity can have an impact on seagrass, and so that's another data set you could look at.
Yeah, maybe picking up on what Evan was saying earlier, that's another potential of linking habitat to some of the other abiotic variables that are being measured.
Yeah, and I was going to just mention Jim Chabot's lab too, also does that work. But it's going to really depend on the students of their experience, because the things I do is mostly like time series type analysis, or straight Pearson correlation statistics. This is going to be in our GIS heavy type remote sensing thing. So if you're looking at post data, then you're going to be looking at image processing, like very old satellite images, to look at the change, right? Because you're going to need what's the change. So that's going to necessitate looking at new and old images, and then actually literally, we were using AI or you to draw where the grass is in the area, which is something that's totally possible with AI to do. But that's going to depend on the experience of what we've got. Right. Yeah. Someone that's really experienced in doing raster processing. That work. Anybody experienced in doing like raster processing or GIS work?
Certainly in CMSS, there is that expertise.
There is, yeah.
And they will be getting training this summer. Even summer visits. Process data.
Yeah. Because it sounds very similar. There's a lot of projects that do that. When you look at the image and then you're literally drawing, okay, this is the area you have. Even things like those projects where they took slides of cells and tried to draw where the cell is, those types of AI learning. I mean, those are kind of well-defined AI topics, but yeah, you just have to get the old satellite, new satellite, and then use AI to draw the seagrass and where it's there, and then just go down a percentage. Yeah.
Patrick, your hand is raised.
Yes, that's precisely what I've done kind of as a layperson. Looking at the Google Maps, you can see the imagery of the seagrasses pretty well. And we have some, very firm points from our study that Camerata has done. And it's kind of, I think the last measurement data was probably 2022. So we're just, a short distance away from when we have our last data point. Also want to point out that we're also doing some monitoring, water quality monitoring here in Ingleside on the Bay. We're looking at turbidity, we're looking at salinities, pH, oxygen, and we have a database that's not quite solid, but it at least gives us some points to work with. We're using University of Texas Arlington's NSF grant, so that may be some other data points. And lastly, I just want to point out that there's some fishery, or maybe it's Texas A&M, Corpus Christi, but every now and then, a couple times a year, we're seeing gill nets being used in Ingleside on the Bay. And they just did one like 2 weeks ago. The water color over here, it's, I hate to say Lake Mathis doesn't look very good, but it doesn't to me. And it is just very, very dirty water over here. I'm wondering what those data points can show us of the productivity of the finfish and some of the species that are targeted by tourists and local people. That's all I had. We could talk more about this tomorrow.
Yeah, just as an inspiration for the students again, I think what we have seen is we have a couple of different data sets. So we have this environmental parameters, we have salinity, we have water currents, the oil spill models. We do have site parameters, we have chlorophyll intensities. We have then, and when we have done some ecological models or ecological data sets, as was mentioned before, we have this seagrass data, which probably you need to prepare a little bit. And we have those the TWDB fish data or catch data. If you are actually able to work in small groups and prepare this data to be actually able to overlay them, this would be a relatively powerful result for different bay areas or specific bay areas in our coastal belt. And I think that will serve a lot of stakeholders, and you can just not affect me right now and say, no, this is not
Okay, with that, let's not forget all the other climatic data that are available. You know, you wanna look at the change in climate and the, I don't know, sea level change and everything else, so that data they're available to mix in. Yeah. But think about breaking it into 3 big ideas that you can maybe potentially bring in together at the end and still answer this bigger question. Right. Any?
So one thing, I think I just looked up the data Evan mentioned, and also Jace had this 5-station very high quality, high frequency measurement of water chemistry, biogeochemistry. So one idea I had was probably, look at the Estuarines up and down the coast, combine the climate factors that include both temperature and freshwater inflow, and look at the activity in estuaries. So.
Okay, if we don't have any more questions, we're gonna take a 15-minute break. Before coming back, and it's going to be a discussion amongst our students on breaking up into their groups. You're all welcome to stick around and be part of that discussion, but for our stakeholders, both online and in person, you are free to go at this point if you wish to also. And we thank you for being here today. Oh, before anybody leaves though, I would like to get a group picture. And then also for your name tag, if you could please leave it on the table on your way out, we will be reusing them. Thank you.